Hello guys, hello everyone. All right. What are we going to do today? Um we were yesterday trying to we were working on the programming language, right, on cast, and we realized that our tests were stack overflowing, right? Hello Nigel, how are you doing? The stack overflows happened yesterday and we tried to fix it. With async, and I want to explore that today more. Maybe come up with like a simpler solution, something. Even Kubi uses Stack Overflow. Overflowing the stack and using the Stack Overflow, I think, is a little bit different. How about hello Raymarch? All right, I'm going to like actually make a new project for this. Uh, we'll see if I can have like something. Let's see, GitHub repo create. So we create a new repository on GitHub from scratch. Repository name would be what? Studied read expression and read one for an hour yesterday. Did you understand it? Do you understand the code now? I think like modifying the root expression and read one to be like not recursive, but to be like to have like the fake stack like you know like make the this thing iterative like you usually would do. It's not that hard, but I don't know. I would like to think more about this problem and see if I can come up with something specifically in Rust or maybe in the future with Cast. You know, what should I call this thing? Something like fake stack, maybe. Fake stack. I'm not sure. I'm not sure. The password. The password for what? Oh, for the GitHub. Yeah, because my token was expired, I guess, or something like that. I need to regenerate it probably. Settings. Settings. Where do you do this? Developer settings, maybe? Personal access tokens. Is this the one? Decursion. Decursion. It sounds like the recursion is a curse, and we are like lifting the curse or something. Actually, it sounds about right. um, do I need a wait? Hold on. How do I use this? The GitHub API from I need to like create the repository. Do I need a token classic or a fine-grained token for that? Let's try the fine-grained one. Hello? Hello, hello. Who was there? Gordianka. Hi. Token name. Expiration. 90 days. Description. What is this token used for? Everything. Public repositories, all repositories, also public repositories, read only. Only select repositories, permissions, repository permissions. Read write, read write, read write. I just have a token that has access to everything. Well, I guess not everything. I just want to like technically just generate the repositories. Maybe, I'm not sure. Repository creation, deletion. Yeah, this thing. What is this? Blue the noob. Hello, Pigorly. Why did you link this? Oh, wait. It's... Oh, shit. I thought it was like... Yeah, I didn't even see that it's Kuvibot. It's the command that actually links this. I linked it. Whoops. Alright. You can watch this beautiful trailer while I am generating the token here. Generate the token. Nice. Copy, paste, unlock. The unlock password was incorrect. Oh wait, this is the key ring. Oh. Repo create from scratch. Okay, decursion. Decursion? Is that the name that we wanted? Right, decursion, sure. Let's have decursion. On the Kuviman description. I'll change the description later. Public, readme, no. Git ignore, no. Don't, I mean, yes, sure. The MIT license, whatever. Decursion, continue, yes. Create a repository locally, yes. Load the new repository locally. Okay, so there you go. We now have the decursion, right? Let's see. Go to projects, decursion. Ah, nice. So we have the license and the .git, and that's it. Nice. All right. Okay. All right. Let's copy from the from cast, I guess, maybe like X here. Let me see. There is some things that I don't really need. The crane, for example, is not needed. Nix filter is not needed. I just need the Rust overlay and the Nix packages. Right. Sure. Packages, import Nix packages, this, Rust toolchain, Rust source, targets. I don't think I need the target, but maybe we'll see. Cast, we don't need that. Packages, system, we don't need that. Dev shells, we have a Rust toolchain, Rust analyzer, and these things we don't need. Shell hook, I don't need shell hook. Whatever. Formatter is this. Checks, we don't need. There you go. Nix develop, or I guess I need to add this. Nix develop dot. Crane flake, yeah, okay, hold on. Self, Nix packages, and Rust overlay. Those are the only three things that I need. How are you doing, Pigorly? How's everyone doing? Nigel, you said you were going to participate in the Ludum there. What are you going to use to make a game? Are you using... Oh, you said Godot, right? With your classmate or something. This is how you're doing? The link to the for Pigorly. Someone raps. Alright, nice. Yeah, I like the unwraps. That code is beautiful. Okay, so we have this. Let's echo use use flake to the env-rc, and then we do the renv allow. Okay. Let's see. We need to now git ignore. We also are going to say cargo init, right? A binary. No, it was supposed to be a library. Librs. Nothing like this. This is an empty library. Okay, sure. Recursion and addition, dependencies, nice. No. Git ignore needs to be length needs to be ignored, I guess, right? It's a dot dirent. That setup dev. All right. I think I need to reload the new of them here. Projects, decursion. Source lib. Okay, Rust analyzer looks like is working. Cargo test is something like this. Okay, let's start by writing a test that we want to fix, right? So what would be the like the thing that is like recursive normally? I think the most well-known recursive thing is like the DFS, right? Maybe. So that's what we should do. The DFS. So we are going to have test function test DFS, right? What do we write the DFS? I don't know. I mean, what would be the good example? When I was looking through the examples yesterday of like this recursion stuff, they were showing the calculating the sum of the numbers on the list. Hello, Infinite Coder. But maybe like the list is a little bit too simple. Let's have a tree. Async is stack. What do you mean? Async is stack. No. Async is not stack. Async is async. Stack is stack. But we're going to use async to fake the stack. How can you fake stack with async? Well, that's what we're going to try and figure out. Let's just write a recursive algorithm which is going to like overflow the stack and then fix it with async. That's the goal, right? That's the goal. And then we want it to be like easily usable or something. So we'll have a tree, and it's either like a leaf node or it is like an inner node, right? With a list like that, right? Something. That how you do a tree, right? So how about we just like have a simple function, you know, like total nodes of a tree, you know. Total nodes of a tree is like the amount of leaves plus inner nodes, right? So we're going to like match the tree, and if it is a leaf, then it's going to be like 1, and if it's an inner node with like the children, then it's going to be like what? 1000. It's going pretty well. I'm just going to do some experiment today, and then tomorrow is going to be the Ludum there. Boom, boom, boom. So we just say that like let result is 1, and then for child in children we say like result plus equal total nodes of the child, right? And then we return that, right? Can this algorithm be like very easily like how would you write this without recursion? Like, it's not really easy to do this with tail recursion, right? So let's try to construct the deep tree. How about this? So we are going to construct a very deep tree. Let mute tree. We are going to start with a leaf node, and then I'm going to do like let's say that I don't know. Let's go. I don't know. Is 1 million okay for the debug build? We'll see. So we are going to do this, and we're going to say tree is tree inner node where with the child being the current tree. Can I do that? You know, so like we have basically like a single child in every single thing, right? So we have like singly linked list this way, right? I mean, we can add like another like leaf over here, for example, another leaf like this, so it's not really like a singly linked list, but like a small thing. Can you draw an explanation in Paint? You don't get it? You don't get what I'm trying to do? This is a simple tree, right? You know how trees work. In general. A tree is something that you can understand, right? Let's, okay, fine. Let's try open a sprite here. New. Do we have a tree? A tree shows good. We'll call it a skew tree. Yeah. So like, so the algorithm, this algorithm, the total nodes algorithm, right? What it's trying to do is it's going to calculate the amount of nodes in the tree, right? It's not necessarily a binary tree. It's like whatever amount of children in anything, you know? So for this tree specifically, if this is like the root over here at the top, right? This is the root. For this one, this algorithm will return 1, 2, 3, 4, 5, 6, right? Because there is 6 nodes in this tree. Does that make sense? And this works like by calculating recursively how many nodes do we have in this inner subtree, right? And then in this inner subtree, and then in this inner subtree, in this inner subtree. So like it works recursively, right? And then what I'm trying to do here in my test is I'm trying to construct a very specific tree, which is very, very deep, right? So that because this is a recursive algorithm, we're going to Stack Overflow right now. We're going to just make a very, very deep tree. And also, like, I added another leaf to every single node, so it's actually going to be like this, you know? I don't know if there's, like, a name for this, like, just so that it's not like a pure list. It doesn't really matter, though. What I want to see is a Stack Overflow right now, and then we're going to try and fix it. Right, so let's like assert the total nodes of the tree. So without recursion is hard indeed. Yeah, like so, but it is possible. It is possible to write this without recursion. Like you can like the general method of like doing this without recursion is like you fake the stack. You like you have like a data structure which represents the current state of the of you processing the thing, you know, the current state of this function basically, right? And then you like you have your like your own stack on the heap, and then you do a loop while the stack is not empty. You like try to like do something with it basically, right? So it's possible. It's just like when you do this, the code becomes no longer like really readable and everything, which is why we want it to be automated somehow, right? What is the total nodes of this tree specifically? Let's see. So we are doing like 2 nodes for every single thing here. Let's make this n const n size is this. So this should be what? Like n times 2 plus 1, I think. Is that correct? Let's try with n being 10. Cargo test. So yeah, there you go. The test works. But if I try to do this with 1 million nodes, then we will overflow the stack, right? There you go. There you go. Will I overflow the stack on the release mode too here? Even on the release mode, right? Because this is pretty big. This is pretty big. So the reason we Stack Overflow is because like the default stack size, I'm on Linux, is something like 4 megabytes or something like this, right? Or like 2 megabytes for like newly spawned threads, something like this. So these algorithms, they don't really like work unless you change the stack size. But the stack size is something that is only known, that like must be known. It's fixed, right? Global stacks is a global stack actually is like global stack. Is that a thing? Any data research on the value and cost of global stacks in the programming languages subreddit. Working towards a native code compiler. Something. Maybe this paper, from folklore to fact, comparing implementations of stacks and continuations. Yeah, this is probably like what I should look into. The continuations is the thing, yeah. All right. Let's just commit this. Test that stack overflows. Nice. So the way I want to fix this, is let's see. I imagine it being something like this. We're going to abuse async. Because what async does, again, is it converts your function into a state machine, right? And then we can like treat the code as value, basically, like the future object that we get when we call the an async function represents the current stack of this function, the data that this function needs on the stack, basically. And then we can put that stack data anywhere we want, you know, and things like that. Can I make sure that this test like stack overflows cargo test must, like, it's not a panic, right? Must stack overflow. Like, there is a must panic, would panic, right? But it's not a panic, is it? It has overflowed the stack. This is a fatal runtime error. Wait, but they do it in a separate thread. So like, can we still do this? If I do shoot panic, like, because this is a fatal error. Fatal runtime error. Is this not a panic? Let me see. Cargo test. Can I not have an assertion that it overflows? Cargo test assert a stack overflow is happening. No, I don't think I remember anything like that. I want to save the stack. Yeah, I want to like save the stack somewhere else. And when I call a function recursively, I'm going to pause the current function. The only way to pause the current function is by using async. And I'm going to like, the future, that is the result of me calling another function, is going to be stored somewhere else. I'm going to pause the executing current function so that we don't like so that the usual stack doesn't grow. We're going to put the current function that we were evaluating somewhere and like basically forget that it exists. We are going to run the inner function that we were calling until completion. After it's completed, we are going to bring the function from which we called the other one back, and then we're going to continue it, you know, something like that, so that it is so that we are not going to use like the normal stack, you know, and that way we are not going to stack overflow. DIY scheduler, yeah. I mean, it's not yeah, we are going to make a simple async runtime. Yesterday I already like successfully did that, but I was using like something that was I just used the async executor from the small runtime, but it's an overkill because our runtime is going to be like simpler. I think I also am wondering if I can do this with Save Rust completely, but I don't think I can. I think I cannot do this with Save Rust. What is this for? Well, for fixing Stack Overflows. That's what it's for. Have you never had a Stack Overflow yet, Nerdsoul? Did you ever have a Stack Overflow? Hello. Have you never written an algorithm like this? I guess usually you don't really have a very, very deep tree structure. We call that the heapster. Yes. Yes, but like we're going to have the stack on the heap, right? Like there's a data structure that's called stack, and we're going to store it on the heap. You had it with infinite recursion or allocating a huge array. You don't think your regular recursion ever went that deep? Yeah, like it depends on the data structure that you want, but like have you ever written a depth first search algorithm? Like on a graph, for example, you want to like see that you can like reach one thing from another thing, right? That's like usually what it's doing. And like if you do this on a big graph, it's just going to Stack Overflow. So over here, this is our example. We're trying to calculate the amount of nodes in a tree. That's the simple example I'm going to fix. All right, let's see. So we are going to say that this is async now. This is async. And over here, we're going to await. Right? We're going to await. Now you can see that this is a recursion. We need to have some interaction. If we just say that this is going to be like boxed, that this is boxed, let's say cargo add futures. Let's add futures light maybe. I'm not sure if I need futures light. If they have it, use futures light. Future, yeah, they do have boxed. Okay, so prelude this, right? So what we're doing is I'm like boxing this future. So technically we're putting the stack on the heap already, but it's not enough. This is still going to Stack Overflow. Futures light. Wait, but they don't have the executor, the futures light, right? Light. I usually just use the normal futures. Oh, there is a future block on. Okay, futures. Let's just do block on. This is equal to that, and let's import the block. Cargo test. So this is stick Stack Overflowing, right? Even although I am boxing the future, so I'm putting these things on the heap, but the problem is that when I'm polling the outer future, in order to poll this future to see if it's done, I need to poll this inner future, which is still like polling the things recursively, and it still is bad, right? But is this forecast or link cider or it's forecast. It's forecast. So the problem is, okay, if you were not here yesterday, right? The problem is that we have like we want to parse something like a plus b plus c, right? A mathematical expression, right? And imagine if this is like a right associative operator, right? Let's say that this is like a function definition, or in our case, it was a semicolon, basically, right? We do A, B, C, right? What this is supposed to be is like semicolon is a right associative thing. So we have A and then B, C, D, right? So in order to parse this, I need to parse this while parsing this outer expression, right? Which means that I'm recursively going like deeper and deeper, you know? So if we have like a very long instruction list like that, we're going to Stack Overflow. And like after the parsing, we construct the tree, and while the interpreter interprets that tree, we are going to also Stack Overflow because it's like a deep one. So one of the fixes could be that instead of having the tree like that, we would like fold the tree into a list or something, maybe. But that's not a generic solution. Can you tail recurse that? like, look at this algorithm. Can you tail recurse this algorithm? Like, specifically the semicolons, I can tail recurse, but it's not a generic solution. Not everything can be tail recursed. I mean, everything can be tail recursed if you use the continuation passing style, but that means rewriting your stuff completely. You know. And we want some automatic solution because we want the code to be still readable and understandable. So we start by marking the function as async. And instead of the box local over here, so my solution that I think we can make working is that instead of saying box local, we're going to say fake the stack. Fake the stack. Or I guess, no, hold on. Decurse, you know? Because that's what we have like named this project. Raymarsh, I guess, named this project. It's called a decursion. Right? So we're going to decurse this thing. Right? And that's what the library is going to be about, basically. Cycle detected when type checking. Yeah. This is a weird error, by the way. Cycle detected when type checking, because like the decurse is something that like we don't know what it is or what. Am I on YouTube? Because I look familiar. Well, I'm exporting all of my streams to the YouTube, but I'm not really editing the streams or anything. Yeah, we have the VODs channel. Maybe you have seen this there. Something there. Let's remove that. Okay, so we go to the librs, and we're going to have trait future ext. We're going to decurse, right? The thing. Function decurse. Decurse. Decurse self. Right? Decurse self. This is going to give me. This is like async, right? So this is do I just do async trait or something? Async function decurse. Self output. Future ext, which extends the future. Right? But usage of async function in public traits is discouraged as an auto trait. Bounds cannot be specified. Yeah. But we cannot be generic over the send and sync, right? So we would need to have two traits for that, right? Decurse and decurse local, I guess. Maybe similar to boxed and boxed local. Why isn't activate Linux watermark there? Do you hate Windows that much? What do you mean? I don't hate anything. I love everything. I love my my Linux. I'm just broke, you know. So I even though I love it a lot, I can't really afford to support it properly by giving them my money because I don't have the money. But my Windows is activated, you know. That's where all of my money went. Windows is installed on this machine too. Which distro am I using? We're using the NixOS. BTW. Alright, let's do this. Async function decurse. This is going to do something like books future. Books future. Self output. Let's do that. Box future. Can I import this? Not use. Futures light, future, boxed. Oh, it's called boxed. Oh, they have a different name than the normal futures, I see. Boxed. Sure. Let's try that for now. Watching my stream from MPV. Now you can control how much latency you want. Oh, you can pause the stream this way? Is that how it works? If you do that? So we're going to implement for all the futures, the future axt method, right? And we're going to decurse it, right? And we're going to like figure this out. So here's the idea. We're going to have our own executor. And when we're saying decurse, we are going to like see that we are running from inside our own custom executor that can do the decursion, basically, right? But unfortunately, Rust is not a good enough language where it does not give us the ability to like statically check that our futures are running within a specific context. So similarly to how Tokyo panics, if you are running some Tokyo stuff from outside of the Tokyo runtime, we're also just going to panic if we are not inside the decursion executor, you know. So we're going to have struct decursor or something, you know, and we need to like have this. This is our executor. And for like having this, we're going to use the thread local docs thread hqt scoped TLS HKT. This is what I want. Scoped thread local storage with higher kinded types. Yeah. Sure, let's do that. This module provides the ability to generate scoped thread local variables. In this sense, scoped indicates that thread local storage actually stores a reference to a value, and this reference is only placed in a storage for a scoped amount of time, so that we are not like limited to static things. But maybe like we actually don't. Yeah, I mean, if we want to like decurse something that like is not static, then we need this cargo add scoped TLS HKT. So we're going to have scoped thread local, which is going to be I just need the runtime, right? So this is like similarly to how Tokyo has like the runtime basically being a thread local thing, right? Thread local static decursor decursor. Do I just do like let's just start with something like arc mutex decursor, you know? How about that? We will start with static stuff. Initially, each scoped slot is empty. Yes, exactly. Okay. Arcs and mutexes. Let's import those things. Maybe I will not need them in the future. Do I make games? Yeah, I do make games. Not right now though. I will make game tomorrow. Tomorrow is going to be the Ludum there, which is a game jam. It starts in 9 hours actually, but I will stream like about the same time tomorrow, I guess. But yeah, we have a bunch of games on the itch. All of these are also made for game jams. The Link Cider specifically, we are trying to turn into a full game, which has a Steam page that you can wishlist it on. But today I'm not doing this. Today I'm just doing an experiment. getting rid of recursion, fixing recursion basically, and stack overflows. Am I doing compo? Are you doing anything? I think for now that I'm going to do compo, but I'm not sure. I'm not sure yet. I think I will. I don't know. Feel free to find a team. I don't know yet. If I will. Yeah, I think it will be compo. Multiplayer. Maybe multiplayer. We'll see. I'm not sure. I'm not sure. It will depend on the theme. I'm not like. Do you think I need to do multiplayer? Raynoid. I don't know. Is Brainerd, you are not like joining for sure, right? Even somebody else, if somebody else asks you to make music for you for them, you still is not going to join. Can you show your itch too? Yeah, sure, you can show your itch too. Just put the link in chat. We can look at this briefly. You're gonna make music, not gonna dev. All right. Let me see here. I need to do something here, right? Cargo test. So right now, decurse is not found on impl future. Method not found. Method not found decurse. So okay, hold on. The reason it's not found is because I need to use decursion. Future axt. Let's just use decursion everything here, right? And then it's going to like, yeah. It's weird that it's not like even telling me that it wants to do this. So we still overflowed the stack, right? We still overflowed the stack. Wait, why did I overflow my stack if I have a to do here? I'm supposed to have a to do error, no? How did I still overflow my stack? Bam, bam. My latest game you're working on. All right. I'm going to check it for a small amount of time though. Not for a long time. Because I'm working on other things. This looks like Godot, right? Tap on the screen. Nice. New game. Okay, so it looks like we are on ice. Because we cannot stop anywhere. Lives? Hold on, I have 4.6 lives? What does it even mean? I mean, 4.6 lives. Oh, level 6. How many levels are there in total? Is level impossible? Probably not. But I think I need to restart the level. How do I restart the level? Is there a restart button? Back, quit. What is this? Oh, I can zoom in and out too. Quit. Continue. Wait. I continued and I'm now on another level. Nice. Are you just making this for just for fun? This is not a part of any game jam or anything. How was I stuck? You could have gone up. Yeah, but like I couldn't like go to the exit there. I'm pretty sure. Like I needed to I needed to undo there a little bit. Anyway. Let's go back to our Rust code. Go back to the decursion. How do I not how do I steal Stack Overflow here? I don't understand. Hold on. Nodes child not decurs. Is it because like I'm technically calling this function, so I'm still constructing the thing, so like I don't even get to the decursion, right? Because I'm like in the because I am in the in debug mode, right? I think hold on, let me just check quickly. If I test on the release mode, is this going to overflow? It is. So just like calling this function constructs hmm. Like I'm not getting here, you know? I'm not. So I'm overflowing my stack like before I get here, which means that calling this function is already like overflowing, right? But when I call this function, since this is an async function, it's not actually like calling anything, any internal function, right? Until we start awaiting it, right? So let me see here, print in out. I'm not even going in. Wait, what? I'm overflowing my stack because... Am I doing this before? Oh, hold on. Wait, what? Wait a second. I think I'm overflowing the stack, this constructing the tree. Wait, why does this overflow the stack though? Stack too small? Yeah, but like I'm storing the things on the heap anyway, right? I'm using a vec here. What is this stack overflow? Wait, hold on. I don't have any output. Let's comment this. And it works. Wait. Is it because I need to do no capture or something? and then we overflow the stack. So hold on. So I got to the end of the oh wait, hold on. I know what happens. You know what overflows my stack? It's the drop implementation for this. The drop is what is overflowing the stack. You know, because this tree is implementing the drop because I use a vec, so we need to free the memory in the end of the test. That's what overflowing the stack. Shit. Hold on. How can I how can I like wait? But I will not be ever be able to fix the overflowing of this stack in the drops, right? So I cannot even like construct such a big data structure anyway, right? Or I don't know. Maybe we need to. I mean, we can have our own implement drop for tree, right? We can implement our own drop for tree, which would do what? Which would do what? Tone. std mem match self. So if I have a inner node with the children, let's just leak the memory maybe for now. But we will need to fix that too, I guess. Which means that like I think we will need to like queue this thing into somewhere else or something. You know? SD mem take children. So this is the children, which is like the back. And I need not to drop it. I need not to drop it. We do forget. We leak the memory. To do. Don't leak. This line does not need to be changed later. Sure. Okay, let's try it again. Let's remove the print because it does no longer need it. Okay, yeah. So yeah, constructing this thing is like I did this specifically like iteration. So like there is no way this can Stack Overflow. Cargo test. There you go. Nice. Nice. So now if we do block on, now we are going to have a not yet implemented. There we go. Yeah, now we have the not yet implemented. So hold on, is the problem the reason I was Stack Overflowing previously is because even if we panic, we still try to run the drop implementations, right? We still try to free the memory. Rust and officials, too many lists, first drop. Let's see. We can make a stack, push to, pop of it, and we've been testing it all works right. Do we need to worry about cleaning up our list? Technically not at all. Like C++, Rust uses destructors to automatically clean up the resources. A type has a destructor with a method trait called drop. Traits in Rust are fancy terms for interfaces. The drop trait has the following interface. Basically, when you go out of scope, you'll give a second chance to clean up your affairs. You don't actually need to implement drop if you contain types that implement drop. All of you do is call their destructors. In the case of a list, this, the automatic handling is going to be bad. Let's consider a simple list. List ABC. When list gets dropped, it will try to drop A, which will try to drop B, which will try to drop C. Some of you might rightly be getting nervous. This is a recursive code, and recursive code can blow up the stack. There we go. So let's take a look at how they solved it in the Rust unofficial book. Some of you might be thinking, this is clearly tailored recursive, and any decent language would ensure that such language wouldn't blow the stack. This is in fact incorrect. Let's see why. To see why, let's try to write that what the compiler has to do by manually implementing drop for our list as the compiler would. Drop, self-head drop. Tailored recursive, good. Note, you cannot actually explicitly call drop in real Rust code. We are pretending to be the compiler. Yeah. We implement the drop for link. We have the match here, and yeah, tailored recursive, good. Okay. But when we drop the box node, we self pointer drop, and then we deallocate. Yes, and that is not tail recursive. Sure, we cannot drop the contents of the box after deallocating, so there is no way to drop to be a tail recursive. Okay, we are instead going to have to manually write an iterative drop for list that holds nodes out of their boxes, right? While this, that, right? And then this passed. Wait, hold on. Yeah, we replace it with an empty one, right? That's literally what they are doing. So technically, I can write the drop properly, right? I can write the drop properly. Wait, hold on. How do you do this again? I don't think we can do this actually, because they do it for the list, right? The list is a single link list. I have a tree which has multiple different like branches, potentially multiple different children. They only have one children, right? So I cannot do it in the same way, right? But we can do it with like the same async trick that we're going to implement. Let's not think about the drop for now, but let's do the actual algorithm first, right? Lib. So decurse. What is going to happen here? What is going to happen here? What is going to happen here? What is our decursor? Decursor is a thing that is going to have the fake stack. So fake stack is the stack of things that are currently happening. Our current like everything that we call recursively, right? Which is just going to be a vec of a thing which represents the stack. So the thing that represents the stack is a future, actually, right? Because yeah, that's what our thing is being converted into. We're going to box it, right? So I guess we're just going to do boxed futures. The output of the future, though, is going to be what? What is going to be the output of the future? Since this is a list, I think the output needs to be nothing. Kind of, right? And also the lifetime. These things have the lifetimes. We're going to have a static lifetime, and I think. Wait, hold on, boxed. Wait, they only futures light only supports the static boxed futures. This is okay. I think the normal futures are better. As a crate, then let me see docs. I need to be able to specify the lifetimes there sometimes. Futures light boxed. Let me see this too. Boxed. Oh, they do pin. They do return pin boxed in future, right? But this is supposed to be the alias like this. Like why this alias is supposed to have another lifetime argument here instead of being static. But okay. But okay. Sure. Let's start with static. Let's start with static because that's simpler, right? Okay. So so whatever is like on the top of this stack is like the deepest function that we are in right now, right? So when I'm decursing, what I'm actually going to do is I'm going to, let's first so we have this thread local decursor, right? So decursor dot with, right, gets a value out of the scoped variable, and then like run something with it. Yeah, this function takes a closure which receives the value of this variable. So we do the with decursor. So this means that we need to have like this future must be pulled within the decursing context, similar to how Tokyo futures need to be pulled within the Tokyo runtime decursor, and then inside we have the decursor here. Right? So with the decursor, I'm going to say that let move decursor is decursor lock unwrap. That's fine. And we are going to say that decursor dot fake stack, we are going to push the current future onto the stack, right? So this is the future that I'm trying to decurse is basically supposed to be the recursive call. So we're going to put this on top of the stack. So fake stack, we're going to push self boxed, I guess, right? Something like this. No method boxed. Can I just do box pin self? F cannot be shared between the threads safely. Yeah, so like let's make sure that this also works for sync, for send. Do I need sync too? Maybe not. Let's see. So we have this. And this future, the self future, must be the one. I'm putting a mutex into a thread local. Yeah. I think we can like I think we are going to replace it with some unsafe stuff instead. Like an unsafe cell maybe or something. You was AFK. What's the reason to do this? So we are going to like the reason is very similar to like how do they implement it in Tokyo? Do you know? Have you looked? Because when you pull a future that requires a Tokyo runtime is stored inside a thread local in a similar fashion, basically. It's our runtime, it's our dependency. In order to like run our futures that require decursing, we need to run them within the decursor. Does that make sense? But Rust does not allow you to statically check. Like there is no way for you to specify that your async stuff needs to run within a certain runtime, right? So we solve this with the thread locals and stuff. But there's an issue somewhere where Rust future custom context or something, custom future context, which would like allow you to do something like this or something. Like, you know, your context in the future, it only like has the it doesn't know that it actually doesn't need to be send or sync. I think since my specific thing here is supposed to run like I think I don't need the send here. Yeah. Well, like I could use like a reference counted ref cell. Actually, like all I need to do is to have a mutex. I don't even need an arc technically, you know. And since this is a thread local, then we just need a ref cell, right? I mean, if that was your question, I guess we don't really need the mutex, and we don't need an arc, right? This is a thread local anyway. Use std cell ref cell. But the reason we are doing this is that is our dependency for the futures to run. They need to be ran within the context of a decursor, you know. So we do a borrow mute here instead. So I guess we do the boxed local then, because I don't need my futures to be send sync either. Like I'm just trying to convert my just recursive function into that, right? Boxed local, box pin. So we don't need the send anymore. There you go. So now the problem is that on our fake stack we're going to store these futures, right? The future is supposed to resolve into nothing, but this future does not necessarily resolve into nothing, so we need to map it, right? So we're going to map our future. Is there a map in like futures light? Let's open the prelude. Do they have the map? They don't. I think I need to not use the futures light. I need to use the actual futures grid map. There is stream map, but not the future map. Wait, what? Why is there a map method for streams but not for futures in the futures light crate? It's not in the STD, right? Like future map is not there. Is it going to be there at some point? Not really. There's a join that's going to be an STD though, it seems, for futures. Yeah. Vac looks it's still a stack. Maybe alt stack. You wouldn't call it fake stack if it's actually still a stack? I mean, yeah. I mean, it's fake, like, it's because, like, the stack, the data structure is not the same as the stack in, like, stack versus heap stuff, right? You can have a stack on the heap, but it's not a stack on the stack, you know? So, do I just, like, it's just, like, the same name is used for two different things. What, like... The call stack is a stack, yes. But this is also a stack, which is also a call stack technically. But it's not like the stack that is like the... Like, I don't know, the stack, like your threads in the operating system have a stack, right? Which is why it's not fake. Yeah, but like it's the alternative to the thread stack, right? Not in your operating system? I'm pretty sure in your operating system too, Pigorly. If you use an array in C#, you would call it fake array? Because it's managed? No. Because an array, no. It's because, like, I'm referring specifically to the stack, which is not like the which is not the data structure called stack, but I'm referring to the thread stack, which is not a data structure. It's like the memory, like how like stack. What is stack? Like, not the stack data structure, right? That's not what I'm referring to. Stack disambiguation, computing, right? We have the stack, and then we have the call stack. Stack data structure that stores information, the current subroutines in the computer program. Is it? No, hold on. Is it called the call stack? Stacks Mac OS, a folder view on the dock on Mac OS. That's what you're talking about. Your operating system, Pigorly. Stack-based memory allocation, a memory allocation scheme based on the principle of first in, last out. See, isn't that what I'm talking about? The stack-based memory allocation? But it is a stack data structure. I mean, yeah, it is. I don't know. Okay, what would you want me to call it? Alt stack, sure, whatever. We're making alt stacks. I'm separating two things that are not separate. Well, there are things like you are separating stack versus heap usually, right? So this is the stack that I'm talking about, the one that is not the heap, you know? like the memory stuff. In most modern computer system, each thread has a reserved region of memory referred to it as a stack. Yeah, so this is the stack that I'm talking about. Exactly, yes. I mean, so like it's a region of memory, and inside this region of memory we have like this stack is a stack, but it's not the stack that Unix processes use by convention. Yeah, but if you build another call stack that doesn't make it fake. Okay, but what does it... Okay, it calls it alternative, not fake, sure. Whatever. Okay, I don't have the map of the futures in the futures light, so I'm going to add the futures crate instead of the futures light. Futures light, you can go. use futures prelude star, right? And this is and the boxed local then. Boxed local is going to be local box future, I think it's what it's called. In the futures, right? And these things can have a lifetime now. All right, we are going to start with the static one though. We're going to start with the static, which means that where self is static, so we're going to only work for static lifetimes for now, right? Where self is static. Wait, what? Where f is static? Where over here self and over here f. Is that so? Wait, how do you... Where f is static? What's the problem right now? Not all traits implemented. You're missing the recurse. It's literally here. Fake Raymarch is not Raymarch, but can still be a Twitch user. If you claim it is fake, the assumption would be that it's not even a stack. Well, it's not like it's not the stack. Yes, that is it. That's it. It's not the it's not the stack memory, you know. So it's not a stack, right? It's a stack, the data structure, but it's not the memory that is called stack. Is a stack not on the stack? Yes. I got a lot of the things mixed up there. Maybe. You all are getting it totally wrong. All right. Maybe. Like... Let's move on. Okay, sure, let's move on. I'm not sure where I'm wrong, though. Does anyone else understand how we are all wrong? Code fake this stack, and then allow the non-snake case? Okay, where I'm wrong here, why do I not compile? Because of the comma. There you go. It's because of the syntax that was wrong. Alright, makes sense, maybe. I think I can use the self here, right? Because self is the same as f, yeah. Okay, so we are mapping the future into... So I'm going to like use the channels. So I'm going to add another crate, which is going to be called async one-shot, which is like the one-shot channels. All right. So I'm going to have a sender and receiver, which is going to be async one-shot channel, you know, like this. You all claim there is the stack, and if the call stack somehow had a unique right to claim the word stack, then it in reality it is called call stack because of the call of the stack data structure property, which is also the whole reason why it is used for function calls in the first place. The property of fast push pop in a contiguous memory. Stack does not need to be contiguous memory, though. It can be implemented as a single linked list. And it would still be called a stack, right? So what's special about the call stack? There is still something special there, right? Lamza Aran, hello. We all like magic. Yeah, we're going to have some magic implemented in a second. So like the result value of my future is going to be sent through the sender. So sender.send sender.send the value, and if it was I'm going to unwrap here because I think it's never going to be closed. Send the result through the sender, which means that the sender needs to be mutable. And I'm going to move it into here. True, but it needs to be first in, last out list. That's the defining property of the stack. Yes, which is why. So like, so what do I call it? A fake call stack? Because a call stack is a pretty specific kind of stack in residing in a very specific memory. The stack police has found him. Like, what do you call, like, there is a very specific stack that is being used in your, like, in your code, right? Is it not a call stack? Then yes, it's a fake call stack. Well, it is a call stack because I'm going to like store the calls there, but it's not the same call stack, so it's not fake. I mean, it's not fake. It's real, but it's like in a different memory, basically, right? So there is a like. I'm moving things around because this stack is limited, but this stack is not limited, you know? Because this is a stack that cannot overflow unless you run out of RAM, right? No reason to think the stacks of the other person is somehow more valid. Well, I think I don't know. Maybe the call stack should not be called stack to begin with, like the memory. Like you have this stack implemented inside this memory, right? But the memory that is being allocated for your thread is just a region of memory, right? It starts becoming thread when you write your program, but you can like use it for other purposes too. You can like do other things, right? I mean, technically there is like the operations in the assembly, right? Which interact directly with the stack. There is like the stack pointer as a dedicated register for it and everything, right? So this is the stack that I'm talking about. The term stack is not used because of that allocation, but because of the first in last out property. All right, I'm just trying to like this entire thing is going to be like 50 lines of code probably, but we are slow because we're arguing about what a stack is. You think the actual thing is different? Understanding of the word fake. Yeah, maybe it's like the fake word is something that I used incorrectly. I don't know. Like how does the alternative stack naming make sense? Because like if this is the alternative stack, then where this is the original stack, right? Like which one is the original one? If all that we care about the stack is that the property of the first in last out, then like this is still like the stack, the normal stack, right? There is nothing alternative about it either. Maybe just call it stack. Let's call it call stack because that's what it is. Okay, so over here we will say receiver receiver. Like technically I don't need to box it. I can return this directly. Oh, how about this? Since this is a public API, how about we don't use the local box feature? We're going to have something like struct, a public struct public struct recursed future of type T, right? Which inside is going to have this like implementation detail, which is the async one-shot receiver of type T, right? Something like this. And then I will need to implement the future for the recursed future, right? Of type T, which would just like call this thing, right? Does it mean that this needs to be pulled? The receiver inside needs to be pulled. Needs to be pinned, I mean. L0 pull context, right? But the receiver output is T, right? No method pulled for receiver. Wait, does the receiver not implement the future? Async on shot. I think it does. Receiver implements a future. The output is a result. So I need to map this or something. No method called for async one-shot receiver. Like, that's not true. Oh, I need to import a trait, even though I'm inside the trait. But the future is... Wait, hold on. This trait is even imported already. Something is wrong with my compiler or something. We cannot call New York the Big Apple anymore because it is not the Big Apple. Isn't call stack alone is sufficient to refer to what you'll call this stack, but stack isn't. So you have a master key. The property of the master key is that it can open all doors in the building. Now you make another key that looks differently, operates differently, but still opens all the doors in the building. Well... Well, this is the thing. What I was talking about is not the key itself, but about what is the but about the implementation of the key, right? What is the key made of, right? So it is now made of something else. I'm not referring to the I was not referring to the key itself, but what is it made out of, right? Naming stuff continues to be the hardest problem in the programming, yeah. Yeah. Boxed local. Let's do that. Result, unwrap. We're not going to actually do that though. I'm just wondering, why do I have this error? Does anyone understand why I don't have the method poll found for struct receiver if the receiver actually implements the future? Oh, it implements it where it's send and sync. Hold on, I cannot do this for non-send and sync stuff. There is no one-shot receiver for like the non-send. I would need to find another crate for it. Sure. Let's start with send and sync. But it still says that there is no method for it. Because it's okay. There is no method because it's not pinned, right? So that's what we need. We need to pin the receiver. Std pin. Wait, but how do I... Wait, is there like... How do I even do that? Self dot... Hold on. Docs std. Can I like from a pinned reference get a pinned inner reference map? Like there is a map unchecked, right? Which would do this, and this is unsafe. Construct a new pin by mapping the interior value, right? So like there is no way to do this safely, right? I just need to use unsafe here anyway, if I want to have this abstraction, I think. Map unchecked. Map unchecked mut. Yeah. This 0 is what I need. And then I pull this because now we have this thing. Let me see. Do I pull? And then I can map the pull, right? Map the pull. Result. Expect the sender was dropped. But this is never supposed to happen. I'm pretty sure that I can unwrap here. The operation is unsafe. Unsafe. Sure. Let's write unsafe. Provide the argument. The context is my argument. Okay. Nice. Children. Borrow data escapes outside of the function. This is static. So now I cannot do this, by the way, because I'm technically like my futures are not static. My futures are not static. In order to like, let's start with this consuming the tree, because that's going to be easier, right? Cannot move out of the tree, which implements the drop trait. Wait. But then I need to hold on. Now I cannot move out of it because it implements the drop trait. So I need to like comment out the drop implementation now or something. TLDR stack is first in, last out list. And they build allocation strategies for function calls, and they notice this is a great strategy. And therefore, they call it the function call stack. Yes. So it's called a stack. But it's a very specific stack, right? Doesn't make the tree a non-tree because it's embedded in an array. Yeah, but like okay, I guess the question is then, Raymarch, what do we like if I want to refer to a very specific function call stack that is in the in this specific like Unix process memory, right? It's not like Unix specific though, right? There is in the current threads like memory allocated specifically for this function call stack. This is a very, very specific stack that we're talking about. Is there a name for it, or do I need to like like say the entire sentence for you to understand which is the stack that I mean? Like usually you just say you use the stack instead of like allocating something on the heap, right? But you like you understand that that when someone says something like this, then they are talking about a very specific stack, right? Most people say thread stack or call stack. No, I think most people say just stack. You know, it's just stack versus heap, and that's it. But they like implicitly they mean like the thread stack, right? Let's see, cargo test. We are going to panic right now because the decursion. Wait, hold on, I overflowed my stack again. Okay, let's wait. Let's see what happened now. I think yeah, okay. So it happened again. It's because I panicked. I need the draw implementation, like the drop implementation, to be here. Can I have a drop implementation and at the same time do a pattern matching on it? in Rust, impl drop and destructuring structs with implement drop. Like I want to have this, right? Because in this specific case, I kind of like don't want to run the drop impl, right? Maybe. Because the problem is that we panic, and then when we panic, we try to run the destructors, and the destructors, they overflow the stack running the drop impulse, so that I don't have the actual panic message. This is what happens here. Maybe if I do the test, but I say no capture. Yes, so like this is the actual panic message that I have, and then after this panic message, we're trying to clean up, and we overflow the stack, running the drop impulse. If you say stack versus heap, it's mostly because of the allocation properties, which again are relevant because of the first in, last out. Yeah, we'll need to figure this out too. Maybe not. Maybe like I will get rid of the static requirement, then we will like have a reference here, and the drop impl is going to be implemented later. If we destruct the stack, we'll lose the destruction. We need to clean up ourselves. Is there like a solution to this problem? Did you ever run into this, Raymarch, where something that implements drop and you want to like destruct it, and that's not allowed by the Rust compiler? It sucks. Yeah, I guess I just do this with no capture for now, because that's how I see the message here, at least. Because overflowing the stack is the incorrect message. I don't care about that. What you sometimes do is add an inner struct, which is drop. And an outer that adds the part that can be taken out. So maybe like instead of this being a vec, or like we can also make a manual drop implementation, right? We can make a manual drop. I mean those sucks, because then I would need to like call the drop manually, kind of. So this is where the drop implementation becomes recursive. If I say that like this is the children specifically, right? Then I will have struct children, which is inside the vec of trees, right? And then I will like implement the drop on this. That's what you are proposing, I guess, right? So like the tree itself does not implement the drop, but the children does. But then it means that I cannot move out of this, because this implements the drop, right? Which means that I need to implement into iterator here. Can I implement and then into iterator? Like I mean, I'm just moving this problem to another level then for children. Let's have the item would be a tree, and the into iter, let's have like the boxed in iterator. Item is tree, right? Can I do that? And so like inside the implementation of this, I would do like self 0 into iter dot and then like box it, right? But then it says that I cannot move out of children. So the way we are going to do this, we're going to take this mutably, right? And then we're going to do std mem take build self 0 so that we don't actually move it out. We replace it with an empty value. Is that the solution? This is so ugly. But okay, I guess it works. Let's implement from back freeze for children. I don't know, this example becomes too big though because of all these things. Right? So now we just have the not implemented in DFS 14. Because the drop is not implemented, right? And we just do, say, like, std, we forget, like I was doing before, and then we take the vec, and then we forget it, right? So that we don't, overflow the stack. There we go. So now we have the actual problem that we had, where we cannot exit a scoped thread local variable without calling set first. This specifically is about this call. Can I have a custom error message here, because the cursor is this like thread local stuff? Can I have something like a try with? Let me take a look at the documentation of that crate again. Docs, scoped, TLS, HKT. We have the scoped key. Right, there is with. This one is panicking. And okay, I guess we do the is set instead of try with, right? So we say something like if not the cursor dot is set, then we are going to panic, saying that you can only decurse when inside decursing context. So similarly to how you require a Tokyo runtime, basically, right? The same thing. You can only recurse when inside decursing context. So now, how do we initialize the decursing context, right? How do we do that? So so we do that. Do we have like a freestanding function or an extension method on the future? I'm not sure. I think a freestanding function would make more sense to me. We would have something like function decursing, right? I guess it's like a run. It's like similar to the block on, right? But it's going to be like run decursing stuff. So we have as an argument the future, where output is t, right? This future is supposed to make use of the decursing, right? This is going to return t. This is where we are going to actually like do the blocking and everything. This is where we construct our executor and shit, right? So we say decursor, decursor dot set, set the decursor to the value. Inserts a value into the scope thread local storage for a slot for duration of a closure. Yeah, so we give it the decursor, which we are going to construct here, and then we call the closure with it, right? But decursor is a ref cell new decursor, where we start with the call stack. The call stack that we start with is going to be the original future, right? The original future, I guess. And we are going to like do the one shot again, right? So sender sender and receiver is async one-shot channel. So the call stack would be so since this is basically the first function that we call, this is going to be on top of our call stack, right? So we are going to say here f dot map result sender send result. Did I unwrap there? I think we just unwrap here. That's fine. And then we do boxed local, right? So this is our call stack. It contains our original future, right? Then we should wait until the receiver actually receives the thing where this this future, which is at the beginning, at the bottom of our call stack. Once it finishes, we finish the this thing, right? Yeah. So what we do is this can have the result, right? Yeah. So just remove this. Do I have receiver dot try receive, I guess, right? Yeah, there you go. This one is not necessarily not a wait. So what we're going to do here, we're going to basically pull our future in a loop. This is similar to block on, kind of, right? So we are going to loop. But the only future that we actually need to pull is the future at the top of the stack, because that's the current like thing that we're running, right? So and then in the end, after this stack call becomes empty, we will receiver try receive unwrap, because like since the stack is now empty, it means that our top future has completed, which means that we should successfully receive the thing here. This unwrapping should never panic. I think so. How do we pull the thing at the top, right? I guess we just say that while let some future is there at the top of our stack, the cursor. I need to also like kind of this is also like interesting, because we have a ref cell. So I need to like borrow mute here. But we want to, while this borrow is borrowed mutably, we want to borrow it again inside, because when we are pulling the future that's on top of the stack, it can potentially decurse something inside and push on top of our stack, right? Let's see. Let decursor is decursor down. It's the same one, right? Decursor, we try to borrow it mutably. I mean, technically we just borrow it. It doesn't matter, right? We say that let some function, some future is decursor call stack last, or else we break the loop, right? So if the stack is empty, then we have successfully returned. That's what it means, right? And also, if this is so now I need to like drop this borrow so that we can do this inside std mem drop decursor, since this is a ref cell. And then after that we need to pull the future, which actually means that this future needs to be also, since This local box future is a pin box, right? I need to poll it. Poll. There is poll unpin and a convenience for calling future poll on unpin future types. And it is unpin because it's a boxed future, right? Or something. Poll unpin. Context. I need to construct the context here. What is a context? Like, we don't really care about the wakers and everything, right? Context is std task context. There's from waker, and I need to like have the waker here, right? What is the waker? Waker is no op waker in the futures task. I have this. Wait, hold on. Can we have futures task? There is no op waker, but is there a no op context? I guess not really. We do this. We construct the context, and then we poll our future with the context. Expected mutable context, found context. Yeah, the context must be mutable, sure. We pull the future, and then basically the polling can result in one of the two things, right? If the poll means that we are ready, this means that the current function at the top of the stack has successfully exited. That's what it means. The result is nothing. So this means that the innermost function in the call stack has exited. So this means that we remove this function from the top of the stack, right? We say decursor borrow mute. Why did this import decursor borrow mute decursor? Oh, decursor is a ref. Okay. Decursor ref. It's called the decursor ref. So this one is specifically a decursor, the original one. We drop the reference here. Yeah. Decursor borrow, and the call stack we need to pop from the top of the stack. We are popping specifically this future here, right? That we just polled. We do that. This must be the same one. Like technically, I think we can like run the decurse and then like drop this future. I think we need to have something that like if the future that was like decursed, if we drop it, then like we need to know about this here, because this over here we expect to see the same exact future that I just pulled. You know, I expect to see the same future. Right? It does not implement the debug. Map error. Can it move out of the decursor ref because it's borrowed? Wait, what? Test requires that sender is something is static. Yeah, so like this future must be static, right? That's what we need. No, I mean the T also must be static, right? Static. That what you mean? The borrow sender as mutable. And then I need to move it here. The sender into this closure. There you go. What about this issue here? Cannot move out of the decursor ref because it's borrowed. Oh, because it's borrowed like over here. Yeah, indeed. Indeed, it is borrowed here. So like because I'm trying to do that. Okay. How about we like because in order to pull the future, I need to have a mutable access to this thing anyway, right? Which means that these things should probably be like something like RC ref celled themselves. I'm not sure. Let's just try to have some implementation here first. But RC ref cell that. So now, since this is the reference to the RC ref cell, I will instead say that f is f clone, so that we don't hold the reference to the decursor ref this way, right? This is like arc RC clone, right? And then I need to borrow mutably this thing and then pull unpin, right? F does not live long enough because this is the wait, why? We have also mismatched types. Call stack push. Over there in the end. Box spin. Arc new. No. I guess we can just do into here, right? The trade bound RC ref cell pin box future from the map is not there. Okay, maybe not. Box spin ref cell new RC new. I guess unless I like if I specify the type of the box, of the pinned box, that would work, I guess. Consider adding a semicolon there. I think that's literally what we need to do. I think this is the first time I actually fixed something by adding a semicolon after a match. Okay. You can also delete decurse when inside the decursive context. So let's see now. Let's see now. We go into the test back here, right? So instead of block on, what we do is we do like decurse. We do run decursing this thing, right? Instead of block on, we do this. Block on does not need to happen. Cargo test. So now we have another not yet implemented lib 36. This one, right? So if the task is pending, once again, if the task is ready, then the innermost function in the call stack has exited, right? But if it's pending, this should mean that we are going deeper, that we have called inner function with decursed, right? Something like this. So we go deeper into the stack. So in this case, we pop the stack. In this case, the stack has already been pushed, actually. We don't need to do anything in this case, because it's just like on the next iteration of this loop, we're going to pull the top of the stack again. I think that's it. Maybe not. Sounds like a really cursed stream. What are you doing exactly? Stack it is in function stack, not in memory stack, right? Yeah, we had a long conversation today. What exactly is the stack that I'm talking about? Call stack, not function stack. We're trying to move our recursive algorithm. By the way, our test has passed. It works. It works already. I have implemented this successfully, it seems. So we are basically, what we're trying to do is we're trying to move away from the so like when you're writing a recursive algorithm, you can end up with having stack overflows, right? That's the issue that we're trying to fix. That's it. So, and the way we're fixing it is that we still want the algorithm to be written in a recursive manner. So it's like, usually the way you solve it is that, like, you, instead of writing the algorithm recursively, you transform it into the iterative algorithm, right? Sometimes you construct your own stack, like with the state and everything, right? But we try to solve this in the automatic manner using async. That's what I'm trying to do. Here's the test. Vac for the stack. Yes, vac for the stack. Here's what we're trying to do. This is the entire algorithm. We have a tree, right? We have a tree. There's a little bit of noise here that I would like to get rid of, but we basically have a tree, which is either a leaf or an inner node with a children, which is a list of trees, basically, right? So a generic tree structure, right? And the algorithm that we're trying to do here is calculate the total number of nodes in this tree, right? So if it's a leaf node, then the amount of nodes is 1. If it's an inner node with children, then we start with 1, we iterate over the children, and then we call this algorithm recursively, right? And everything. I wonder if you can make it so it's actually in the contiguous memory, maybe like with Bumpalo. Maybe it would have to be in pinned chunks. Yeah, it would have to be in pinned chunks. So like yeah. We have some implementation right now, but it's far from perfect, I guess. But yeah, this is a problem because we need the pinned futures, right? Because the futures that we are putting onto this stack are like potentially self-referential, so that like if our vector in the implementation, if our stack gets reallocated, then this can potentially like break. Right now I'm not using any unsafe, am I? Unsafe. I am using unsafe over here for, but this is safe. This is safe. This is fine. It's just me getting the I'm just making a new type over another future, and that's it. It's safe. In C++, you'd call it deck. What exactly would you call deck? You have a deck in Rust too. A deck is something that can like be like pushed and popped from either side, basically. You call it a vec deck in Rust. In C++, the std deck is a bunch of chunks with elements. In Rust, it'd be different. I mean, like the implementation. I don't know how to implement it. I used the std deck before, but in Rust, it has no pinning guarantee. Does it have the pinning guarantee in the deck? So every single chunk never gets moved, so they don't reallocate the memory. Oh, that's okay. So I guess we could do the same thing in Rust then, right? And this means that I would not need to like to box the futures technically, although like the things that I'm storing here is a boxed future anyway. The RC ref cell can be replaced with the unsafe cell, like this like the overhead of this we can get rid of by doing some unsafe. Right? Is it possible to measure stack usage in Rust? I'm not sure. Can you do it in C++? With like the val grind maybe? That's the main reason why people use stddeck in C++. You'd love to have an equivalent in Rust? I don't know. I used stddeck before in C++, and the reason I was using it is because it's because it's a deck, because of that's the property of the data structure that I needed to be able to pop and push into both sides, unlike the queue or a stack, which first in, last out, first in, first out. I never cared about like where it's placed in memory. before. I was using it a lot when I was doing the competitive programming back in the day. Let's see. The test works, by the way, which means that the idea is working. So here it is, right? We have the recursive algorithm, and all we need to do is to call a decurse method on a recursive call. So this is a recursive call to the same function, right? And we just say decurse. And then we also mark everything as async await. But this is a fake async await. Do you agree, Raybarsh, that this async await is fake? Or is it like the real async code? It's easy to shoot yourself in the foot with the std vector in C++ if you type erase the elements and forget they are trivially movable. Yeah, I was never like using the move semantics in C++. I think like the move semantics in C++, they appeared when in C++ 14, right? I think, or was it in C++ 11 already? I think like it started appearing when I was stopping to use C++ for anything. I think C++ 11 was not very widespread yet, or something. How is it fake? This async await? Well, because let's have the copy of this function, right? The copy of this function that is actually what we wanted to do originally is just this. So this is the normal recursive algorithm, right? You know, how do I call it? Not fake. Broken total nodes, because it's stack overflows, I guess. Let's have another test. Test broken, and test decursed. So it's cursed and decursed, I guess. Test broken. This broken is like literally the same, but we, instead of running decursing, we'll literally just call this function. Test nodes broken. Broken test nodes. So you see, this function is literally the same. It does not have any async. This is just implementing the same algorithm. But if I try to run this, we're going to overflow the stack, and this. So this, it's not really async in a sense that, like, we don't like run two like recursive two recursive like things concurrently with each other. There's only one thing that is actually running, the most deeply nested call of the function, you know. So it's kind of fake. Like if you try to use this in combination with another like with like other async code, like with Tokyo, I'm not sure what's going to happen. I don't know. But it's supposed to just fix our sync code to no longer be stack overflowing. They lead them to add all kinds of wacky APIs in all sorts of places. They led the move semantics, yeah. I guess. How trivial the conversion is in Rust. Make it a crate, call it fragmented call stack. But I literally called it decursing because you suggested the name. It's similar how the generator creates a misuse async. Yeah. So like technically generators are implemented on top of async await, right? But you can implement no. Async await is implemented on top of generators, but you can do it the other way around. You can implement generators using async await. There's also some effect libraries in Rust. Right? Rust effing med, I think, or something like this one. Algebraic effects in Rust that you can also like. Is this done with async? I'm not sure. Yeah. No, maybe not. I'm not sure. But you can have the effect systems with async and shit. It's just like a little weird. Let's just say that it works right now. Can I say that the test, like since this is broken, say don't run, ignore reason. This test stack overflows, right? Yeah. I also did like the other thing, like I guess like the Stack Overflow fixing is something that like most of you understand what I just did, right? At least like the problem that we're trying to solve. But the other thing that I did, the switch resume crate, which allows us to have delimited continuations in Rust. I think most people don't understand what this is, right? I think no one understood what I did here when I did that. Maybe recurse is a bad name because it's still recursive. Well, it's like recursive, but not. It's fake recursion. There's a lot of usage of the word fake today, I guess. It's fake recursion. Can we say that, Ray March? That was my original name that I wanted to give it. The fake. Well, I wanted to have it to call it the fake stack. Fake recursion, I guess, is more like it because it's not real recursion anymore. We don't actually have recursion. We indirect the recursive calls into like the other thing. Let me commit this thing. All right. Proof of concept is working basically, right? Yeah. In case you want to look, I'm working on GitHub over here. We already called it decursing. I think we don't need to rename it. Decurse. Is it decurse? Wait, hold on. Which is it? Decursion. Decursion. There you go. So if it is decurse, then there is incurse somewhere. All right. So the problem with the implementation right now is just like I'm doing a little bit too much allocation, right? I'm like boxing my futures using RC ref cells. We can make it better by doing a little bit of unsafe, I guess, right? So I think the most obvious thing to start with is instead of doing RC ref cell, I would do an unsafe cell here. I would say spooky recursion. Unsafe cell, I think, is the thing that makes sense. So how do you construct it? I never used this before. I think it's just unsafe cell new. Is there such a thing? Yes, there is. This one is safe to construct, right? Construct new instance which will wrap the specified value. Stack Overflow fixer. I don't know. I like the name decursing. It's okay. There is no such crate, right? That exists on the crates.io. Decursing. There is a decurse. Wait, hold on. Why did we not look into this before? There is literally the same thing with the same purpose. The macro to make recursive function run on the heap, which means no stack overflow. Why did I not look at this? This is 004 though, not even 01. You had that happen to me twice. Make a library that already exists. I mean, there's no way I'm doing something that no one has done before, right? But I'm guessing that they did not make it Yeah, like they're not making it async, right? I'm assuming. I'm not sure what is their implementation. See the README for the overview of this grid and how to use it. The only things that we have is two macros, so simply put them above your recursive functions. But like I mark specifically like the places where the recursion can happen. Like do they treat every function call as something that like they do or something? They also have the unsound macro limitation in the README. Let's take a look at the README. Drop bomb. Is drop bomb the same the thing that you implemented and then you realize that it's already possible? Appears to have no README file. Drop the bomb by matclad. Is there a create for every word possible? I mean, there's a lot. 3 million downloads? Wait, what? What does this do? Where's the documentation? Drop bomb provides two types, drop bomb and debug drop bomb, which panics on drop with a specified message unless diffused. Oh, okay. So like you need to diffuse the bomb. All right. Drop bomb. Yeah, that makes sense. I don't remember that if I ever, so like you need this because we don't have linear types in Rust, right? That's why. Because like you want to make sure that you use the thing. Yeah. So you plant a bomb and then you need to defuse it. Makes sense. And you had the same idea and call it did the same. All right, cool. I don't remember like where like when I needed it. I needed this a couple times though. I think I just ignored the fact and didn't do this myself. It's like all our stations think alike. Let me take a look at this decurse. What did these guys think about decurse? So they have the example of the factorial, right? So the factorial is obviously a recursive algorithm, right? And they make it instead of recursing like Fibonacci DFS. So I made a DFS basically, right? The macros provided in this grade make your recursive function run on the heap instead, works on stable Rust. Here's an example to illustrate the mechanism. There are some weird symbols here, the factorial, the rec, and everything. If we call factorial 1, the following will happen. We run the code in the function starting point. When we reach the point this, that one with the recursive function, right? We don't immediately call factorial 0. Instead, we save the information that we have to call this. Basically the same as I'm doing. Once the information is saved, we pause the execution, store in the state of the heap. So like the question is how do they pause it? Do they not use async to do this? Because that's the only way that I know of how to pause a function, right? Do they? And then there's like the unsound version too. This is the version you should prefer. This does not use unsafe code and this does safe. However, it does not on functions with lifetime parameters. Yeah, I did not make the lifetimes yet. This macro can cause unsoundness. See example. My unproven belief is that if a function compiles without this, then putting this should be safe. This version does not suffer from the limitation of the same version. Limitations. The same version only works with functions without lifetime arguments. Owning ref create is great for working around this. This is not tail call optimization. You can still blow up your heap. Yes. Function only. Alternate recursion is not supported. But I do... Wait, hold on. Oh, but I support alternate recursion. So my crate is better. There you go. Still makes sense to publish my crate because I support alternative recursion. And they don't. Async functions are not supported. I'm wondering if I can like use this in existing async code. I need to figure out how that would work. Struct methods are not supported. Freestanding function only. I can support that. Like the only like right now the current implementation only supports the static ones, so we need to like figure out the lifetime. I'm pretty sure that I don't know like if we need to mark everything as unsafe or we can make like the API to be like to be safe still. I'm pretty sure we will need to like use unsafe behind the Because basically, like, we have the call stack, right? And right now I'm storing the box features with static lifetime, right? But the thing that actually happens is that something later in the call stack can reference something in the earlier call stack, right? So there is no way to like even describe something like this in Rust, right? So like the last element of the vector should be able to like have the lifetime connected to the previous element. There is no way we can do this, right? You wonder if Tokyo is faster than mine because I have a better allocator. Call it decurse by better. Well, we called it decursing, which is like the same thing. But yeah. Benchmarking. I'm also wondering what is their implementation. This block by Hurry a Bit inspired me to make this. The main idea is basically the same. Mine is more hacky because I want to avoid generators. So they were doing the generators. So I use async await instead. Hold on. They literally do it the same way. Stack safety for free. Okay. In 2021. I demonstrate how to abuse generators' coroutines to transform any recursive function into an iterative function with nearly zero code changes. Nice. Yeah, like it makes sense that I'm not inventing something. I'm just wondering if this is solved in any other programming languages, like in a similar way, but like maybe built into the language somehow. Well, now I am a name repo because they came first. Welcome to my world. You are saying that I should not publish the crate because it's a similar name? Like I need to make the name more different than the recurse? Okay, well here's the article that does the same thing that I'm doing here, right? So no need to write the article about this at least. Nice. Do I need to publish a crate? I don't think I need to. Anyone going to use this except for myself? SICP with homework tasks solving on stream when? What is SICP? Do what you like. You gonna make food? All right. SICP. Structure and interpretation of computer. Contribute to it. If there is something to add, like to the existing crate. Like I have a different thing. They solve it with a macro. I don't have a macro, so it's kind of less magic, right? It's kind of less magic, kind of. Modules for macro only, private for use in the macro only. Repository. Must macro to make recursive function run on the heap. No Stack Overflow. I googled it twice already. So you want me like to read the book and do this thing on stream? And that's the book about making interpreters or something? I don't think that I need to do that. That I want to do that. Why would I do that? I can make an interpreter without reading a book. It's fine. We can reinvent our own wheels here, as you can see. I was starting to make the unsafe cell so that this works a little bit faster. Maybe let's can I have something like a benchmark? How do we do cargo bench? Let me first do this. Revert everything. Cargo bench. So how to write a bench? Anyone wrote a benchmark for a Rust grade before? We just do something like benches. Benches. Like, can I make the same test, but like I just want to know how long does it take to run this? That's it. Cargo bench. But I want to run the same code. Do I copy paste it then? And then I would like need a benchmark or targets in test mode. The bench attribute is currently unstable. Okay. I cannot do that anyway, right? Unless I use nightly. Let's just do this. Let start is std time instant now, and let's just print decursing. Okay, finished in start elapsed, something like that. Using debug. Cargo test, no capture. So this is in debug mode right now, right? In debug mode, it runs in 3 seconds. And then let's just, I guess, test the release mode. So in release mode, it's 800 milliseconds. This is just a million nodes that we do, right? Maybe we should also like say here something like constructed tree in start elapsed, and then we say that start is once again the instant now, something like this, so that we don't like calculate the time. I mean, the time to construct this tree is just 80 milliseconds. Maybe using Hyperfine or Divan, yeah, maybe, I don't know, I never used this, but like this is the test, and I want to like just know how long this tests run, right? Or can I like, I don't know, Hyperfine command line benchmarking tool. Like usually when you do the benchmarks, you're like trying to calculate the mean, max, average, right? So you like run the same algorithm multiple times, but I'm running a long algorithm. So this is for more like benchmarking like fast code, right? No? Am I right or no? Like I don't need to run this test like 10 times to understand. Right? Like they have the estimate because they're running the same function 10 times in this case. I don't need to do 10 times. I don't know. We'll see. Let me just do it first this way, maybe. So yeah, 800 milliseconds is kind of a little bit too much, I think, in order to calculate the... like, all we are doing is we are calculating the amount of nodes in the tree, right? Constructing the tree, so actually allocating the memory for it took 80 milliseconds, but running this took 800 milliseconds. That's a lot, right? But we want to do But we want to do the profiling, I guess. Maybe cargo flame graph. Let's install cargo flame graph. Cargo flame graph. Can I run the test? Test. And this is a specific test, right? Test. Test. I called it DFS. Maybe let's rename the test too. Oh, like this is a specific test. This is based on the name. DFS. Okay, and then flame graph in SVG over here. Let's open it with that, I guess. So test the cursed. I need to open this with Firefox, right? Firefox. Which is it? Flame graph SVG. Damn. So what do we see here? The scoped TLS set. M protect sys m alloc. I'm allocating stuff. I'm allocating a lot, right? That is it. The decurse. The decurse is allocating because I'm boxing my futures, I'm assuming. Maybe. Or maybe is it like the async one shot that is allocating or something? I'm not sure. That's let me add the flame graph SVG and perf data to the ignore file. Lazy git doesn't work anymore for some reason. I'm not sure why. Still. Tone. Cargo flame graph. Source lib. All right. Oh, I guess like the allocation happens because we do the RC new, right? And that is the thing that's doing the allocation, and like box pin is the same thing, right? I don't think I can do this without like boxing my futures though. So like this thing is going to stay, but this thing can go, right? We're going to use unsafe cells. Unsafe cell. All stack is unsafe cells of local box futures. So I don't need to clone this anymore. Also, like this ref cell is kind of also can be unsafe, I guess. Let's just not have the ref cells at all. We're going to use unsafe cells only, right? Safe cell new. The cursor dot get mut. Cursor gets a mutable pointer to the wrapped value. This can be cast to a pointer of any kind. When casting to this, ensure there is no mutations or mutable aliases going when casting to this. Yeah, so we do get as mute like this. No field call stack. Wait, mute the cursor, I guess. Otherwise it doesn't understand this. Consider borrowing the value. Wait, hold on. We don't cast it, right? Since this gives me a pointer, we need to do mute star, I guess. Is that how you do it with pointers? Then we do unsafe. So this thing is the unsafe. Okay. Safe cell. Over here we're doing the same stuff, right? Decursor in this case is unsafe. Mute decursor get, right? Decursor is a row pointer. Mute star. There you go. And then over here we don't need to do this. Okay. We just see decursor get unsafe decursor unsafe mute decursor get full stack last. So we construct a mutable reference to this. Now we get a normal reference to our unsafe cell, which is totally fine, right? I don't need to drop anything anymore. This is the unsafe cell, so we're going to do unsafe mute star again, and then we pull and pin that f get, right, like this. Okay, let's cargo test. Okay, so we improved it by 200 milliseconds by doing this, right? The test still works. I'm pretty sure this is totally fine what I just did here. Blazingly, okay, slowly moving towards being blazingly fast. Use unsafe cell instead of ref cells of RC ref cells. Okay, let's see now. So is it the box spinning that that happens so much? Cargo flame graph. Okay, let's see here. So it is still like over here the allocation, the scoped key with is doing the allocation inside, right? Oh, wait, hold on. So decurs, okay, hold on. So decurs calls allocation directly and also calls allocation inside the scoped key. So inside the scoped key is like this closure does the allocation, right? Which is this box spinning, I'm assuming. And then there is some allocation outside of that. So I'm assuming that the async one shot is yeah, it's doing the allocation here. There you go. So we need to get rid of the async one shot dependency, I guess. To do that better, I think we are just going to use the maybe uninit here, basically, for storing the result, right? Like, you know how like if the future that I pulled, how do I do this? Wait. How do I do this here? So the future that we the future when it's ready, it has a value, right? And this value needs to be passed to the function that is up the stack, right? Yo, Togglebit, thank you for the raid. Hello there, guys. A little bit. Thanks for the raid. We're doing something really cursed today, and apparently the thing that I'm doing has been done before. But we are trying to solve the recursion problem. You know how when you write your recursive stuff, you can get stack overflows? So we are fixing that, so that you can write recursive programs, but have no stack overflows. And we're doing this by abusing async in Rust. Apparently this has been done before by the crate that is called decurse. My crate, we called it decursion before we knew about the existence of that crate, so I just found it in like 5 minutes ago without using tail recursion. Not everything can be done with tail recursion. But usually even like you say tail recursion, it means that you need to rewrite your algorithm. We want it to be automatic so that the code is still readable and easy to understand what it does, you know? Here's my test. We are doing the, we have like the tree data structure, which is either a leaf or an inner node with some children. This is just a vec of trees, so like a generic tree structure, and I'm doing the algorithm which calculates the total amount of nodes. So this over here, the broken total nodes, this is the normal algorithm that we do, you know, just a normal recursive function, right? We calculate the total number of nodes in the tree. If it's a leaf, then it's 1. If it's an inner node with some children, then we like add up the total number of nodes in the children and then like have this as a result, right? So this is a recursive program, and if you try running this, then it's going to Stack Overflow on a big tree, right? And and over here, this is the same function, but using like this crate that I have done, which is doing the decursing, which allows us to write the algorithm in the same way, but we don't overflow the stack anymore. Yeah, that's it. Let me extract this. Damn. You use a loop instead of iter? Where? What do you mean? Quick, Gabe, hello. I'm doing great. How are you doing, guys? Using for loop instead of iter. Like, what do you mean? Like over here, this is a for loop, yes. We could do iter, map, and sum, I guess, over here. But you cannot really do that with async. That's a little bit more complex, right? I mean, you can kind of, like, there's, yeah. You're looking like at a for loop right now. Yeah, what's... But it's a loop which calls, like, this same function recursively. That's the important part. The loop is not the important part. It could be a binary tree, in which case it would not be a loop. We would call this function on the left child and then on the right child, if it was a binary tree instead. Extract constructing tree. Pound. But yeah, we're using this by doing async await. Here is we also found an article. Let me just link you guys an article. I just linked it a second ago, which explains exactly what I'm doing, but like that article was using the nightly Rust feature, which is the generators over here. Stack safety for free. They demonstrate how to abuse generators coroutines to transform any recursive function into an iterative function with nearly zero cost code changes. So like we literally invented the same thing here. So yeah. Why did you pin the cast? I'm not working on cast today, but yeah, you can guys also look at this other project that I'm working on. And also tomorrow we're going to participate in the Ludum Dare if anyone is interested. The Ludum Dare is starting in 8 hours, and I'm going to be making a game in Rust tomorrow. You couldn't tell the difference what I'm working on? do you ever look at the code that I'm writing? I mean, I know that you are looking at all the things. I don't know how you do this. You're looking at the source code of everything. In Rust BTW, yeah. Okay, I'm trying to like make this run faster basically. So I changed some RC-ref cells into unsafe cells. So that should be fine. Now I think the next step would be, let me ignore the perf data old, I guess. Ignore old perf data. So I'm using the async one shot, which is doing allocation in order to do that, but I don't really want that allocation to happen. So instead, what I'm going to do is so I need to have like a smaller like alternative to this, which is probably like using a little bit more unsafe. But the problem is that this future returns the T. This also returns the local box future. So I'm doing the, oh wait, hold on. Maybe it's not the one shot. Maybe it's the fact that I'm returning the local box future. How about I returned the recursed future. I even like made this. I even made this recursed future as a like the public thing, but I'm not using it. I'm instead boxing my future. Let's just do this here. We return the recursed future with the receiver inside. There you go. Let's start with this, and we are going to return the recursed future. FS future output, yes. Yeah, but the receiver then. Oh, yeah, hold on, no. Everything is fine. We just need to copy this over here. This should be like self as future output, right? Like this. Test, no capture. Okay, this improved the performance more. Like another 150 milliseconds was deleted. Right? Let's do the flame graph again. Boom. Okay, so now here is my function once call once. Run test closure. Like, what is this function? F and once call once. Future poll. I mean, it's pretty obvious that the biggest thing is this scoped TLS set, which is and I'm pulling the future inside. Total nodes closure. Wait, hold on. Don't I like need to? Yeah, I'm profiling without the debug info. I need to enable the thing. Profile bench debug is true, right? Profile bench debug is true. I did that. But I'm doing the release profile. I think because I'm supposed to do this in the release, right? Not in the bench profile. Is the bench profile something new? Supposed to do this in the release. Did I read any books on how to do async Rust? Nah, not really. Before async Rust existed, I had I had my own futures which were similar. I don't know. I don't know. It just made sense to me. The only book that I read is the Rust programming language, the official book that I read in the very beginning when I did not know Rust. That's the only book that I read. And then the book that I read before that was the book that I read like 20 years ago, probably. I had a book in my childhood which was like something about OpenGL. Don't remember exactly the name of the book. Like something computer graphics OpenGL. Like when OpenGL 3 just released somewhere after that. And I didn't even read that book. I just had it. I opened a few pages of it that I was interested in, and that's it. I'm not really into reading books. I read articles though that people post. Like it's really interesting to read the blogs of the developers of Rust and like what they want to add to the language. You know, like the Nico's log, like without boats blog and those things. You know. Um, um, uh, did I run the profiling already? Okay, there we go. So let's see. Okay, now I see the flame graph properly. STD thread builder spawn unchecked. Catch and wind. Try do call. Run test. So this is me spawning a thread for every test, right? Because every test runs in its own thread. All right, then we do this, and that. We run the cursing. This is the actual function that I care about. This is basically all the scoped key set, which is run the cursing closure, which is, let's open this. So this is the closure. This is the actual stuff that we run. This is me initializing the context. Right. Then we just poll our futures a bunch of times. Inside the polling of the futures, we do total nodes closure. So this is like the most amount of time, right? Which is calling the decurse. So yeah, this on the right is the iterating. So like this chunk is me allocating the iterator, because like in my test I'm doing over here into iterator is boxed in iterator, but I don't need to like box here. I can get rid of this thing on the right at the very least. That's easy. So instead of boxing this thing, we just we say something like vec tree as into iterator, right? And then we just do this and iterator, and we don't box here, so that we should get rid of that now thing on the right. Okay. So yeah, this is no longer there. That's nice. Okay. So now it's just the decurse function itself. What is this on the right still? This is drop in place. Okay, I actually don't care about that part. You used to get books with basic code and you would have to type in the code yourself to play the game. Where do you put the code in? On the computer? Or do you play the game in the book? Like... Was it back in the days where the computers didn't exist yet, Vigorle? Or are you not that old? Wait, when were the computers first introduced? When was first PCs invented? In 1971? First personal computer? Did you have that thing, Bigorley? The Ken Beck? First common ones was the Commodore. In 1976. I don't know. Well, I guess I did have a computer when I was young. I'm not sure if we had it like immediately when I was born or not. But I started programming pretty early, so I don't know. In the 90s, they were pretty common, I guess, already. Good. Not by a personal computer in 1971. There were only mainframes then. You had an IBM XT before C64. I think the first PC that I had was something like Pentium, maybe. Like that's what was in the 90s, right? Pentium stuff. In 1993 it launched. Yeah, I'm pretty sure like something like that is what we had there. And then the first things that I was doing in the computer was playing Half-Life 1, I think. Or maybe it was not the first thing. When was Half-Life 1? And like the 2 days ago? 1998. Yeah, so like I was 6-year-old then. Did I play it as a 6-year-old? There's no way. I probably played it later. But maybe I did. I don't know. Would you guys give your 6-year-old child to play something like Half-Life? I'm pretty sure that I is like... Oh, my no? I don't know. Like maybe I was like... I'm pretty sure that at an age of 10, I have most likely have played it already. The first two common computers were the Commodore, the Apple II, and the Texas. The first three. All right. Let me see if I have improved anything here. I think I did, right? I did. So we go into this Dickers. So one shot, async one shot is taking almost like half of the time, right? So because this is trying to do an arc, new arc is constructing a box. Wait, in order to make an arc, they make a box? Is that inside the implementation of the arc? They make a box? That's so? Arc new. Do they have... Yeah, they construct a box inside, indeed, with all the things. Nice. And then they leak it. Makes sense, I guess. Okay, so we don't want to use that, right? How do I make sure that I don't do that? So we need to get rid of the async one shot over here, right? So we basically we call our function, we get the result, and then I store the result somewhere, right? But I still need to store it somewhere. I think I store it in this recursed future, actually. I think this is literally when I store it. So instead of having the receiver, we just have the data here directly in the form of maybe an init. I mean, we can do an option or something, right? But this needs to be like... But this needs to be pinned, right? Or something. Like, because... We need to like make sure that it's not moved then. If I get reference to this directly. Otherwise, we would need an arc. How do I not allocate here? Or we use something like the allocator inside the decursor, which is like a different allocator, so it's much faster. Something. So here's my my thread local stuff. And over here I can like have like the the innermost function that has completed has a value, but a value can be anything, right? So I need to allocate enough memory for it, right? So how do we say memory? Memory is just vacu8, right? Kind of. And then we like reinterpret this vacu8 as something else. Can I have like, you know, how do I call this? Returned value. We can make something like unsafe, not even unsafe cell. The return value is down. I mean, we can just do RQH as like a memory, right? Why is it even an arc? It's just like a boxed slice, right? Something like this, which represents the memory that allocated for the returned value, right? That's how we do it. Return value. This box is. Do we have these things in Rust? Or do I need to have the I need to construct a vec first and then do the into? Or is there... I mean, I can use a vec directly, but... Slice. I mean, we can have the allocator directly, right? Allocator. Global allocator, allocate. It needs a layout. Is there a more generic stuff to allocate the thing? Like, how does the box work? What is it calling under the hood? Box. Box new. Source. Hello, JD this on DN. I have no idea how to pronounce your name, but hello. New box, new. Oh, it's just Rust box, which means that it's like, what does this mean? It's implemented in the compiler. So box, wait, hold on. Box new is implemented as box new. Okay. Layout, so we construct the layout of the maybe uninit t. Why do we construct a layout of the maybe uninit? Isn't the layout of the t the same of the layout as the layout of the uninit t? Maybe not. Prefer match over unwrap or else. Disclosure sometimes is not inlineable. I don't know. Let's fine. Let's use a vec. It doesn't. I think it doesn't matter. We just need to enough memory for storing this stuff, right? Vacuate. This is some data, right? And we will reinterpret this data in something else, right? Oh wait, but I mean no. Yeah. Over here, we will say something like, so instead of sending, we are not using the async one shot anymore. We can remove this from the dependencies, right? We can remove this from the dependencies. Maybe we don't remove this from dependencies because I'm using this over here too. This one is just like doing it once. It doesn't matter. Oh, it doesn't matter. Like what we get in the end is the returned value, right? Yeah. So we say unsafe, mute the cursor, get returned value of type T. So like this is going to be a generic thing. Let's see. So on the decursor, we will have a function, this unsafe function, get returned value, right? Which will return the T, and we do this, right? So how do we do that? We do std mem size of. Well, but hold on. If I store this in a vec, then I can like this would not be saved because of the alignment or something, right? It should not always be in the beginning of the vec, right? Can I make sure that like this or something? Std alloc layout. An instance of layout describes a particular layout of memory. You build layout as an input to give it as an allocator. All layout has an associated size and a power of 2 alignment. Yeah. So like it's because of the alignment. Is there a maximum alignment that is there so that I can so like over here, if I say something like U128, it would be always aligned like with whatever. Is that how it works or not? No idea. I'm just going to write something cursed and that's going to be completely wrong. But let's try again anyway. So what I want to do is I want to do std pointer read, right? I want to read a pointer. Read unaligned. Reads the value from source without moving it. This leaves memory in source unchanged. Unlike read unaligned works with unaligned pointers. Behavior is undefined. If any of the following conditions are violated, source must be valid for reads. A source must value to a properly initialized value of type T. So like, but this T may not be initialized, may not be like aligned in memory. That's fine for me, right? I'm not I like if I never construct like a reference to an aligned struct, that would be fine, right? Unpack struct, attempting to create a raw pointer to unaligned struct filled with an expression such as packed unaligned creates an intermediate unaligned reference before converting that into a raw pointer. That this reference is separate and immediately cast is consequential, huh? I mean, there is more stuff here. I think we okay, let's just do read unaligned then. I guess vacuate is fine. So we read unaligned in the self returned value, and we do as ptr, right? But this is the pointer to the u8, and we cast it into star const t, right? Read unaligned, and we do this, right? So instead of sending, when I'm sending something, we say downtown back new the cursor hit star call stack push this. Let's do that instead. Let's also do with capacity 1 maybe. I mean, what's the default capacity of the vector? When I pushed it first, I have no idea. This operation is unsafe. This is indeed unsafe. We just wrap this entire thing inside the unsafe. So instead of sending, we say over here, mute the cursor yet. Wait, can I have the method to be like over here? Can I say that self is star is a reference to unsafe cell self? Is this a proper method receiver? Looks like it is, right? Can I just do this? Unsafe function push push the future is import future and do I do this self save cell so over here we say that the cursor dot push like that. So we have get return value, and I will also have the put return value, which is going to be this. Wait, hold on, invalid self parameter. Why did they not have me this Rust custom self receiver or something? I'm not sure. Types are valid for the self parameter of the method. We have box, mute, and everything. Why not safe? The pointers also don't work. I'm assuming then, right? Arbitrary self types. Where's the documentation for it? Originally pool. Prefer self types. Okay, whatever. Let's just do this. How about this? So instead of self, we say this. It's okay. This is okay. No field return value. Oh, okay, so we say something like that. Let this is mute star this, right? Unsafe cell cannot be the reference. No. Mute this dot get, right? With a star. There you go. This is what we need. Okay. So instead of pushing, we say over here the cursor push the cursor that, right? Okay. Now over here we when we get the result in the end, we say the same thing. We say the cursor put return value put return value is this, and the value of type t, this returns nothing, right? The implementation here would be std pointer right unaligned overrides the memory location. So the memory location is still this returned value as pointer, as mute pointer, right? As star mute t, like this, and the value that I'm putting there is this. But we need to first make sure that like there is enough memory there, right? So we say something like self, like this this returned value. There is the truncate, which shortens the vector. Is there like a same thing to like ensure that there is enough size, like resize, I guess, right? Resize so that this is equal. And I like, can I change the capacity? Capacity. Set, allocate, reserve. Reserves the capacity for at least these additional more elements. Reserves the minimum capacity for at least additional more elements to be inserted. This is for additional elements. Like, I don't need to initialize this memory, you know? But I can reserve. Okay, let's memory needed is std mem size of t, right? Is that how we do it? And then current memory is this returned value capacity. If memory needed is more than current memory, then we reserve additional, meaning memory needed minus current memory, right? That's what we do, maybe. Decursor push. All right. So I think this is technically also something that I don't need. So we just push the original f here. So the future here, when we push a future, right? When I push a future, we do this thing. This call stack push the unsafe cell, where we have the future mapped. I don't know. This is boxed. Yeah, we can still box this thing, I guess. Map a boxed local. I put into this the result, the returned value. Do I inline this here? I mean, maybe I do. Because put return value is only supposed to be like here anyway. Right? That's the only place it's been used. So the size of value, then size of value of the result is what we need here. As mode star, I don't name this here, right? The value is the result. The parameter input future may not live long enough. Cannot move out of this because it's borrowed. Wait, this is a reference. This is a reference. Yo, Cakes. Thanks for the raid. Thanks for the raid. How's your game going? Did you figure out how to get more clicks? More click-through ratio? That's what it's called, right? What I'm working on. Hello. I'm doing something really cursed right now. 2,000 impressions on my game is great. 1,000 more than you. Isn't your game like longer there? I'm not sure what I did though. Like we didn't do much. Like I did that one Reddit post and like put the trailer on the YouTube, I guess. And also have been streaming. And you're a more popular streamer. Maybe I don't know. Maybe it's because like it's newer. Also, right? It's going to like go down over time. These numbers, right? What is that font? This font is called Mona Space. We have the font command. I think this should work. Mona Space Krypton. This is it. Innovative superfamily of fonts. There is multiple of these. I'm using the Krypton over here. What language is this? I'm writing Rust, and I'm doing something cursed. So like, here's the problem that I'm trying to solve today. I'm doing some experiment, and so far it's good. I just need to work on performance a little bit. Like, let's say that you're writing C++, right? Because you're guys coming from Cakes, and you are writing something that is a recursive function, right? If your recursive function is going to recurse a lot, you're going to have a Stack Overflow. So what we're trying to do here is we're trying to automate a way to fix the Stack Overflow without rewriting the logic from being recursive. Does that make sense? Where's that blog again that I have? Oh, over here. Stack safety for free. Stack safety for free. I guess there should be like similar thing in Rust. I have only found this blog after I have implemented my stuff here. But basically, in this over here, they demonstrate how to abuse the generator's coroutines, which is exactly what we're doing. We're abusing async await in Rust. There are coroutines in C++, I guess. So we can transform any recursive function into an iterative function with nearly zero code changes. So yeah, this means that we're not going to use a lot of stack space, and we're not going to Stack Overflow. We are instead moving the stack into the heap and doing something cursed. But it allows us to leave the algorithm as is. Here's the test that I was working on. It's very, very simple. We have a tree data structure, which is like basically either a leaf or something that has children, right? And we want to calculate the number of nodes in a tree, right? This over here is very simple, I think. You guys should be able to understand it. If it's a leaf, like if it's a leaf without any children kind of tree, then the amount of nodes is 1. And if it is something that has the children, then we need to iterate over the children, calculate the number of nodes inside, and then add all of those together, and that's going to be our result, right? So if you try to run this on a tree, which I construct like this, which is like a very, very, very deep tree with 1 million nodes, in this case, if you try to do this, you're going to Stack Overflow, right? And this is like a normal function how you would write this, and we make a library which allows you to convert this into async, to abuse the power of async, to decurse our function. When I do this, we basically move the inner function call into the heap, and we don't recurse, we do something really cursed instead, so that it doesn't Stack Overflow. That's it, basically. We're doing some magic. Does that make sense? I guess something like that should be possible in C++ too. So like usually when you have some problem like this, you you refactor your algorithm from being recursive into like being iterative manually, right? But that's a lot of work, and the code becomes less readable as a result, I think. It depends on the actual case, but yeah. Moving return pointers to the heap. It's more like moving the call stack to the heap. That's what we're doing. Here's the implementation. We literally like have the call stack, which is the futures. Future is like the coroutines, which is basically like partially calculated functions. We store those on the heap. You know? Don't coroutines already do this? Not really. They don't. I mean, I don't know how what is the implementation in C++. If you just like make this a coroutine, does it solve it directly? I don't know. I mean, we can try writing some C++ to see if I'm wrong. How to write C++ code, guys? Let me see here. All right, let me stop what I'm doing. Git, easy git. Progress. Let me just check out a new branch or something here, and we are going to write some C++ then. Sure. Check out C++. We're going to install the compiler here, right? The GCC. Is that all I need to have installed? Is that NeoVim? Yeah, it is. It's the front end for NeoVim, which is called NeoVide, which gives me the animations though. Let's have a simple example, right? Test.cpp, right? Can I do this? Include std. How do you do this? Hold on. Int main returns 0, right? G++, dash 03 test cpp. This gives me, and then we do a out, right? Okay, sure. Let's try this. So we're going to have include IOStream. Yeah, but like we don't really care about that yet, right? I mean, yeah, sure. Let's include IOStream, and let's use namespace std, right? Whatever. Let's have a struct tree, right? Which was going to have like children. Children is std is vector tree, right? Can you do that directly like this? Wait, hold on. This is not how you write C++. Vector tree children. Right? Is this how you do? And you do semicolon. Okay, include vector. Semicolon after the struct definition, of course. There you go. Okay, let's construct G++ main cpp. Let me just do a just file and like just file just cpp G++ test cpp. I will use the O3, right, so that it's fast. Or do you guys want me to use O2? Sure. And a out. You'd ignore a out. That's it, right? So I'm working like developing my own programming language. Yes. The problem that I'm solving is because I hit this when making my programming language. Just CPP. Okay, that works. Okay, let's first construct the tree, right? Tree construct tree. We say that tree is tree. How do you initialize things? Can you do this? Like there's the initializer list, right? Children is equal. Is that how you write it? Vector. That's probably not how you write it. Oh my god, this error message is beautiful. Children was not declared in the scope. Class template argument deduction failed. Vector tree. This doesn't seem like game programming. No, it's not. I'm going to do the game programming tomorrow. The Ludum there is tomorrow. I'm doing the. I'm going to participate in it in this if you are interested. It starts in 7 hours. The Ludum there 56 game jam. Children was not declared in the scope. How do you initialize the structs in C++, guys? Do I need to create a constructor, or do I need to do like tree? children. Is this not the initializing list? I'm doing game dev in Rust too. Yeah. I have a Steam page of my game over there, the link cider. If you're interested,
Can you recap, please?
It's a puzzle game. I don't know if you have seen this before. We won the baby jam with it. Just have side powers, side effects. Dot before children, maybe? I don't know, maybe. Show them my itch games. There's also my itch games, right? But this is my main game. There's the farting game. Some of the Cakes viewers probably have seen the Beans of Power, where you fart to jump, and it's like the Phodian stuff, like Pogo Stack and shit. I want to finish that sometime too. Okay, this worked actually. This works. I guess I don't need the tree on the outside, right? Yeah, there we go. Return statement is not returning void. Is this why is this a warning and not an error? Over here, because I'm not returning anything. Return tree. Okay, so we just do something like this for int I is 0, I less than. Can you do underscores in C++? No, you cannot, of course. Can you have a number literal? Maybe this? Is this how you do number literals in C++? I mean, that works, it seems. What else? Then we do something like tree is we initialize it again, where children is vector 3, and then I say that tree dot children dot push back the previous tree. I don't know, something like this. I don't know, children. No, not let. Shit. Order. Children is vector 3. Children push back the current tree. Wait, this is going to copy it though, right? Isn't it? I want to do like the move here. Oh shit, C++ is so weird. Otherwise it's going to copy this. And it's going to like be quadratic time. Oh no. Or do I just say in place back and then it's just going to work? Does it automatically create the move constructors for me? Anyone knows if this code is even correct? Tree is construct tree. There's no way. I have compiled this with optimizations. There's no way it does not like do this. What's wrong here? What's wrong with this code? What's wrong with this code? I think it still is like copying it here because I did not create my own move constructor. Is that it? Is that it? So it's like actually is quadratic time still. I think that's what's happening here. How about we do something like this? No, not let, tree, new tree. No, hold on, I cannot, like, wait, what? Hold on, I'm confused, actually. I don't know. How about okay? We do it the other way. We initialize this tree the other way. We do tree star current node. We like push into the back instead of like constructing from the bottom up. We will construct top down. You know, instead current is tree, right? We do this. And then over here, we will say something like current dot current children. Current children push back, and new one where children is a vector 3. That's how you do it, right? And then we say also that current is current children 0, and we take a reference to that, right? That should work, I think. Expected primary expression before. Oh, because this should be this one. It crashed. I think we have a seg fault. My C++ is a little rusty, guys. It's been a while. C out I and L. I remember that though. Wait, I know exactly what's happening. We are stack overflowing, right? Is that right? This is the same issue that I had in Rust, in C++. So the problem is that in order to like when over here the main finishes, we need to run the destructor of the tree, right? And in order to run the destructor of the tree, we need to like destruct the children. And when I'm destructing the children, I'm destructing the inner children and everything. And we do this recursively, and we stack overflow. I need to heap allocate. This is heap allocation. The vector is allocated on the heap. I'm pretty sure this is the stack overflow. Here. Segmentation fold is also like if you stack overflow, it's going to be also segmentation fold, right? There is no dedicated like thing for it, or is there? Like I'm pretty sure I have constructed this. Cout tree constructed. Pretty sure that this happened. Let's see. Tree constructed, yes, see? Tree constructed, and then we crash. Guess why? Because of the destructor of this shit. Same issue as in Rust. The this thing. How do I forget? How do I not run a destructor in C++? Is that possible? In Rust, we do. How do we leak memory on purpose? C++ disable destructor. Preventing a destructor from running in C++. Maybe I like do I implement my own destructor and then like it's going because like and that's it, right? So it's just we're running the default destructor. Am I right? If I just implement tree here, which does nothing, it's going to be fine. No, it's not fine because it still is like doing these things, right? Maybe. Does anyone know how to make it not do that? You can see that there is no one destructed. Neither this. I would guess that types as the optional are implemented in a similar way. Wait, which way? Nobody mentioned completely C++ standard compliance solution with union. Oh, we need a union. Because if we use a union, then no constructor or destructor is called automatically for members. Oh, okay. So we need a union. No, this is annoying though. If I make this union though, does it work? Can I just mark this as union? This doesn't work anymore. Use of deleted function tree. Use of deleted function tree. Your allocation tree on the stack. Once tree is out of stack, it's deallocated without a destructor. Yeah, I know. Oh, you mean like if we return a pointer instead of returning the actual thing, right? So we can say that tree is new tree, right? Is that how you do it? So this is just a pointer which we never delete then? Is that what you mean? Tree star. Okay, tree. Okay, now nice. So I have constructed the tree. This works. Let's now do this thing, right? So we have a int calculate nodes, right? Calculate nodes. We give it a pointer to the tree, and then we say that basically like int result is 1, and then we say for how do you iterate over a vector? Don't you have like these things in tree children? Does this copy it? Do I need to reference it or something? I'm not sure. I guess what I can do to the old way, right? For auto iterator is tree children begin. It is not tree children end. It plus plus. And we say result plus equal calculate nodes on the do I just do this and it's like going to be casted automatically, return result? This is an iterator, yeah. Or do I like dereference it and then this is going to give me the pointer? Can it convert tree to tree? Like, do we need to do this? Tree constructed, and then it works. Okay. Hold on. Why does this not Stack Overflow? What if I remove the optimizations? It doesn't Stack Overflow anyway. I never called. Oh, that's why. Cout. Okay, int result is calculate nodes on the tree. Cout result is result. Okay, so there you go. We Stack Overflow, right? I'm pretty sure that's what's happening. What about the release? I'm pretty sure release is still going to Stack Overflow, right? It does. What about O3? Still does. Okay. If I do this to be 1,000 instead of 10, instead of 1,000,000, this is supposed to give me 1,000,000 and 1,001, right? So like this technically works. So you say coroutines and C++. C++ coroutines. C++ 20. I probably need to like compile with std C++ 20 or something, right? Don't I do this? std is C++ 24. Is there 24 or something? Did you mean std C++14? No. Is it lowercase? C++24 is not there yet, right? C++20. Okay. So I'd be 2a because like 224 is not there yet, right? Safe C++ is not yet merged. Coroutines. So we make it a task, right? And we have the co-await, right? There is lazy and there is generator. Suspend execution until resumed. I mean, hold on. Who said that we can solve this problem with coroutines? So what do we do now? Coroutine. Coroutine handle promise. Promise type is promise. Huh? I don't need to like construct my own coroutines, do I? A function is a coroutine if its definition contains any of the following: the co-await expression to suspend, the co-yield expression to suspend, the co-return to complete execution. Okay, well, let's await. And then we await something that is also a coroutine. Is that right? So do I just do over here? The calculate nodes inner is supposed to be co-await. And this is a keyword, right? Co-await. Coroutines require a traits template to do task. Task. Task has not name a type. What? Or is it like int, like this? Int is not a template. What the hell is a task? Is it std task? Don't you include anything? Am I bad at reading documentation? Include coroutine, maybe. Task does not name a type. Okay. Wait, but what is it like? Wait, hold on. A function is a coroutine. What is the return type of this? A task is the return type. I assume that task is some coroutine task type. Oh, so like task is, they are assuming. All right, my bad. They were assuming that task is some sort subroutine. Avoid bad 3. Coroutine. Coroutine is this. Coroutine handle. Promise. Promise type is promise. What the hell does this even mean? I'm too lazy to read this all. Here's the code. All right, here's the code. If you know how to make this with coroutines so that it doesn't stack overflow, let me know. Let me know. And let's delete everything else that's like rust here. This, that, right? Okay. C++ only. Task type? I don't know. Task is just undefined. I don't know. I'm like I don't know how coroutines work in C++, but I'm assuming it's something very similar to the Rust futures. You see how C++ has the lifetimes. I literally see the word lifetime on my screen right now. Where's the borrow checker? I guess it's coming. It's coming. GitHub, Kubiman. Decursion. Decursion, C++. Over here. Here's the code. Test C++. I don't know. If anyone is interested in trying to make this work in C++, and like if you think that coroutines solve this issue, then show me how they solve it here. Maybe. Right. Now we can go back to Rust. Yes. And in Rust, we had this working, right? Except I committed something that was not working, actually. Because simple future might not live long enough. So, okay, this future must be static. Can it move out of this because it's borrowed out of this here? This get this PTR. This PTR is this. So we are going to say over here let this is mute this PTR. Right, so that issue is solved. The candidate something didn't find the value receiver, so this is like the same thing, right? Over here we just say the cursor I'm going to push the future, which is self, right? That's all I need to do here, actually. That's literally all I need to do. The cursor cell operation is unsafe, of course. I mean, it is. Cannot find value receiver in this scope. Recursed future. I mean, recursed future doesn't even like need to have anything in it, you know? Recursed future is just, well, I guess it's going to have like phantom data inside, maybe. Phantom data type T, I'm not sure. So recursed future, phantom data. All. So actually, whenever I poll the recursed future, it should work like this. The first poll should be pending, and the next one should be ready. That's how we work here. So I guess we are going to have phantom data is this. Data is this. We are going to say polled is a boolean. Polled is false. So we are going to over here match self polled. If it was false, then we return std. When we return poll pending, right? And we also say that self polled is true. If it was true already, we're going to make sure that it's going to be poll ready, and now over here we need to get the stuff. So we're going to unsafe. We're going to do this with the decursor. Unsafe decursor get returned value of the decursor. Maybe. Cannot mutate immutable variable self. What? Cannot assign data to a dereference. Self as mute. As mute. In target. Get immutable reference. What I do here? Self. Like, how do I access the data inside? Get mute. It has a mutable reference to the data inside of this pin. I guess I do this. T cannot be unpinned. Consider using the pin macro. Wait, what? You know, because get mute is only implemented for the unpins. Yeah. Well, T is. Wait, hold on, no. It's the mute self that is not unpinned, right? This case. All right, let's just do some unsafe. Which one is the unsafe one? Yeah, unchecked mute, right? This one. I think this is fine. Context in this case is completely ignored. Yeah, I don't care about the context. You just jumped in, but as you were checking on C++ reference and now writing Rust, is that so compatible, similar? I think Rust and C++ are the most they are very like each other. Mostly. Like the like C++ is this is the safe proposal, safe C++ proposal. Is this like something C++ is getting borrow checker, you know, I'm pretty sure you guys seen this, right? safec++.org. Like C++ is becoming Rust anyway, right? Like it's just a little behind right now. You know? Feature on safety, STD2 and everything. Like the ideas behind C++ and Rust are basically the same. You want to have like zero cost abstractions and like and shit, right? That's the most important part, I guess. I just Rust is newer, so it doesn't have the problems of the past. Not yet, at least. I mean, these like specific features might like be different a little bit. For example, the move semantics in C++ is kind of weird compared to Rust, because like when you move something, you need to leave behind an object that is still valid for some reason, you know. I think that's like kind of weird, but I guess the reason they did this is because of like because the borrow checker is not there, so like so that it's not that easy to shoot yourself in the foot, I guess. Maybe, I don't know. Use associated syntax instead. Unsafe. Yeah, unsafe. Decursor. Decursor, get returned value with the decursor. Cargo test. Okay, look at this. We have 300 milliseconds now. We started this by having like the safe implementation with arcs, ref cells and shit. I'm adding a bunch of unsafe stuff now, which makes this thing even more cursed, I guess. But I mean, sometimes you have to do this. It's not a lot of code, right? It's just 100 lines of code for now. So we did this 3 times faster. What about if I try to do this? Like I want to compare it with the normal recursive version, basically, right? So how about we say that n over here I'm going to like measure the performance of the recursive one, which is supposed to Stack Overflow, but it is not going to Stack Overflow if I reduce this. Like, I don't know, let's do it at 1000. Cargo test. Release no capture, exact. Test broken. They say ignored. How do I run the ignored? Include ignored. Include ignored. Okay, so this runs in 100 microseconds. Maybe we can like improve this until the increase the number until it overflows. This Stack Overflows already. This doesn't. Okay, 1 millisecond. Left when you were still writing C++, what happened? To C++? I don't know. I feel like figuring out the coroutines is going to take a little bit of time. I'm not really that interested in learning coroutines in C++. Unless someone just shows me how to do it. I'm going back to Rust. I have improved the performance 3 times compared to the original implementation already. Okay, 1 millisecond this, and if I run the cursed one, then that's going to be 3 milliseconds. So like the implementation, so the normal function that you would write normally, that is just recursive, is 3 times faster, right? It's 3 times faster basically. Right? Because yeah, so we need to make it 3 times faster, the recursed version. So instead of running the 1 million in 300 milliseconds, I need this in 100 milliseconds. That would be fine, right? Let's see, more unsafe, more speed. Okay, so if I try to benchmark this right now again, then we are going to, where's my benchmark? Over here. Can I make the dark mode here? It doesn't work on, like, the dark reader doesn't work on the local files. I cannot even enable it. I'm blinded myself. Run recursive closure. So we have the so this is deallocation. Deallocation, the dropping does a lot because we have boxed in futures, I guess. Okay. And over here, as you can see, this big chunk is box pinning. So this is allocation over here, and this is deallocation. And I think if I get rid of this, then we will have the thing. Maybe we can just like use an arena. Can you background in CSS? It's fine. I think we just use arena or something, you know? Yeah, like box new in, right? Docs std new in, right? Is this this is still nightly only, right? The allocator API. Is this going to be stable anytime soon? Allocator trace and std heap. I don't know. They say the remainder of this post is... Oh, okay. I thought the remainder of what is left to be done. Reallocate in place. Lib. So the allocation happens. The allocation happens in the boxed local over here. This is the thing that I need to get rid of. So my futures, my coroutines are using dynamic dispatch. Basically, is what this means. Right? We can use dynamic dispatch without the thing, right? return the value. Like I can do the same trick here with like the memory. And like put my futures there without. So like over here, we are already like on the heap, right? I can, instead of having unsafe cell boxed future, I can have like storing the is there such a thing? Hold on. Like what I want is a storage, a vec of din trade in Rust. Can we do this using a vec din, but like without a reference, right? Because like, you know what I mean? Like every single din trade is like differently sized, kind of. Like I think it should be possible to implement that. I think maybe we just do arena. Right? Bumpalo or something like this. Bump allocation is fast but limited approach to allocation. Yeah. So we do a bump new and then we do vac new in, but this isn't this like nightly? When a boxed carrier feature is enabled, a fork of std boxed box is available. Oh, okay. I have a forked stuff so that I can use the new in. Nightly allocator API. Yeah, like can we do this on stable? And collections means that they have their own vector, right? I mean, I don't need to allocate the vector itself, I guess. Let's do cargo, add a bump. Hello. Sure. Features, boxed. Features, collections. Pound. So we will have over here this boxing. This local box future is going to be. So we are going to have like the allocator lifetime here, I guess, and these futures that are boxed are going to be like allocated in this thing, I think. Let's see. Can we have Bumpalo boxed? Is there a box pin? We need a pin box, right? Because that's what the futures need to be there. Pin. Let's see. We just say local box future, but we are going to not import this. We are going to say that type local box future at is equal to pin box in future. Output is t plus a, right? Something like that. Unsafe cell decursor. So I can have the lifetime here, right? How does this work again? Scoped TLS HKT. Higher kind of types. We do 4A. 4A. Sure. Oh, the cursor needs to have the same thing, right? Unsafe cell does not have a lifetime. The cursor in this case is unsafe cell. Need to move out. Mismatch types. Let's see here. The cursor. Could I just do static here, for example? Consider removing the borrow set. Wait, it's because we need a reference there, right? Is it? No. How to use this? For A, full A. Mutable higher kinded types. I need to remove this borrow. I mean, yeah, I need to do that. Then value is moved, which means that I actually need to borrow it here. Wait, how did this work before? We need a reference here, right? The cursor does not live long enough because it's not static here, right? Any the cursor declared here, borrowed value does not live long enough. Lifetime may not live long enough. Lifetime B defined here, return in this value requires that B must outlive static. For A static, what? Oh, I don't need the mutable thing. This is the unsafe cell. For A, B, A decursor B. I do that. Expect identifier found this. I think this does not support more than one lifetime, maybe. Borrow might be used later here at line 67. Borrow might be used here when the cursor is dropped and runs the destructor for the type. Do I just do let result be this and then I do result to be returned? Does not live long enough. Well, now I have a skill issue with Rust. Because the struct in unsafety is invariant over the parameter t. Yeah, that makes sense actually. Hold on. That's the thing. I'm not supposed to do this with unsafe cells, I guess. Can I have this without the reference? And they cannot move out. Sure what's happening anymore. I am not sure what is happening. I mean, I can have my own implementation of this, I guess. Either removing the burrow, then the value is moved. Let's have RC and save cell. Import RC. Import RC. Let the cursor is RC new decursor. Let's do it at reference counting so that I will like clone this here, I guess. Can I? Still says like that I cannot move out or something stupid here. Why do you want to move anything out though? I don't know how this macro is implemented, I guess. Maybe I need to mute mut. Let's do static decursor, static mute. Can I do that? Static mut. Decursor. Then I don't need it to be an unsafe cell, no? Can I just do this? Mutable reference to the decursor. Like this. Can I? So like, I don't think I need the unsafe cell then. Does it mean that I just do the mutable reference here? After all, itself, so it's like easier. Instead of this, I use self. But then I need to have the self pointer. Star what self is self. Do that. Um, So we don't clone it here, we instead set this to be a mutable reference to the decursor, right? Like this. We don't get that. We do over here. We do decursor dot with cursor. Let's comment this out for now. Everything commented out. To do. Let me see if anything else does not compile here, because we have like the lifetime issue still, right? Maybe this is wrong anyway. The cursor does not live long enough. Like, why does it not live long enough? Because it's supposed to live for the lifetime of something, right? For A, B, expected identifier. So like I cannot make these lifetimes different, right? Higher kinded things. There is only one thing here. You can implement the trait yourself. Doing the reborrow mode. For mutable HKTs, the types must implement the reborrow mode trait, and the result associated type should be self-type with a lifetime substituted with the traits lifetime parameter. That means that like this is just a single lifetime, and then like shit, maybe. So the problem was that it's not implemented. But it's not complaining about it. Reborrow trait is not implemented. It's not saying that, right? Mutable references are invariant over the type parameter. Yes. So I cannot like even have this there, right? Is it because this okay, this is used inside the local box future, which makes like the variance very specific here, right? I guess. How about I undo everything? How about I undo everything that I did here? Let's try again. Let's try from scratch. What's the problem that I have? The problem is that we need to improve the performance, right? So we need to get rid of this boxing, right? Undo cast, bake to Haskell implementation. No, I don't think we're going back to Haskell. Let's see. Let's see. Maybe in order to like so I still added the bumper, right? So I can do this in the thing. Rust will work. It's just the ever common skill issue. I mean, what I have right now, like it like you might have a skill issue. Like what I'm trying to do right now, it works already. The problem is making it work fast, right? Making sure that we don't do anything wrong, right? Like if I was writing C++, this would like appear to be easy, right? But like having the like how do I make sure that that there is no bug? Like I can write a much more unsafe stuff here, but we need to make sure that it's the correct unsafe code, right? Still is the thing here. But let's try. Um, so I need to like allocate something inside an allocator, basically, right? Inside an arena. That's what we need to have, an arena. You know, we need to have an arena, and this would be like a list of like pointers into that arena, maybe then, so that the boxed futures are inside that arena. Something. Can I have the allocator? Allocator is Bumpalo bump, and then arena to bump allocate into. So like just this, right? Allocator is bumpalo bump new, right? That's all I need to do here. So then over here, this future is something that I need to move to the heap. Right now this exists on this stack, right? But I need to move it onto the heap, which means Which means what? I think we just make it a pointer, right? I think we make it a pointer. Let me see. Do we need an unsafe cell? We're going to pretend that this is still static here, but it's not actually static. We're going to like use some unsafe magic, I guess. This is not actually static. W. All right. Let's see. Let's see over here somewhere. I need to do that. So like, so instead of doing this, we need to do something else. Let's see. I need this dot allocator dot. What is the methods that we have on the allocator? On this one specifically, right? On the bump, we have allocate. This gives me a mutable reference to the t, right? Sure. I guess that's all I need really. We allocate this there. We'll have this a pointer, and we will convert this into a box, right? Which means that, oh, wait, hold on. Do I even need the local box future? Can I just have... Wait, but does the allocator never move the memory, right? I guess it doesn't, right? Because that's the allocator. It never moves the memory around, right? Does it? That would not work. If it did. Yeah. Sure. So self-allocator, allocate. So I'm going to allocate this future over there, right? And we get and we will convert this into a pointer, And then we will make it, yeah, sure. We will have it a pointer. So this is a future. This is now stored inside. Consider giving future explicit type, because this underscore cannot be inferred. What's the type of the future though? It's this future f. I don't want to name the type though. And in this vector then we will store just these pointers, I guess, not even unsafe cells. We're going to store the pointers to mutable pointers to dynamic futures, where output is nothing, right? I think that's what we do. So we don't do the unsafe cell. We just have this pointer directly, and we convert it to a mutable pointer, dynamic future. What is this, right? Consider returning the local binding future. Okay, there we go. This is literally what we need to do. So so we allocate this inside the arena, right? And return this as a mutable pointer to the v table, basically. That's what this means. Right? Right. Then I need to also like deallocate, right? But deallocation is going to be handled by the allocator itself, right? Actually, no, I would need to like deallocate those. How do I deallocate them manually in the allocator? I guess I get, wait, do I even do that? So this means that when I'm allocating this, I need to like, I will need to like drop them manually, run the destructors manually, right? On my futures here. So I need a like, I need to drop here too, I think. Anyway, let's see how bad this is going to be first. So have a Dean future. So I just do that, right? F is last. I'm just going to like copy the pointer itself, right? So the pointer itself is this. And now pull unpin. Now we need to like pin it, right? Like it's pinned inside the allocator technically, right? So the memory is supposedly not moving ever, right? I think. So what we want to have, so the F right now is a mutable pointer to the dynamic future. What we want to have is we want to have pin mute. Yo, Coffee Lava is here. So many raids today, thank you. You missed the part when I was doing the C++, guys. There was a little bit of C++ today here. You're going in circles. What do you mean? You're trying to leave the stream, but the other streamers keep sending you back to me? All right. What did the Coffee Lava work on today? The Squid Game. All right, we're doing some magic with async. What do you mean by fake the stack? All right, you want me to explain this to you? Maybe like you checked out the SDL3 GPU. All right, did you make something working with it? Did you write the SDL3 GPU shading language? Did you use that? They have their own shading language, right? If I remember correctly. But yeah, what I'm trying to do here is, do I still have this thing opened or not? Free stack safety for free. Okay, here's the article that I found while I was working on this thing. But basically, we want to make sure that our recursive algorithms don't stack overflow, right? I'm not sure if you like it's not very often that you write some code that stack overflows, but sometimes like you write a simple DFS, depth first search algorithm, and it just stack overflows, right? So what we want, so like usually when that happens, you rewrite your code into being iterative, but it's like it requires a big refactoring and shit, right? So instead we fix the code without changing the code much. So that we basically abuse the coroutines, async in Rust, coroutines in C++, I guess would be as abused to convert the recursive function into iterative function. So you like move the call stack into the heap kind of thing. Does that make sense? So whenever you call a function, you don't actually like go and like increase the and like you don't go into the next like frame in the call stack, you know? You pause running current function, you store it somewhere safe, and then you like run the inner function, and then like once that's done, you put the current you get the current function like back, and then they continue executing it so that you don't have the stack overflows basically. Did that make any sense? Do you understand? And then I have the working implementation. I'm just like trying to do the optimizations, like working with a bunch of unsafe code that I usually don't do. Store stack frames in the heap. Yeah, exactly. That's what we do. So yeah. Pull unpin. Pull unpin. So what I want to have is I want to have a pin mutable din future output is nothing. I think that's what I want to have. Bold of you to assume that I'm allocated on the stack. Easy. Like the problem is not where you allocate. Like all the local variables. Like if you call a different function, the local variables are going to be on the stack, right? I'm not saying that you are allocating anything on the stack. Here's our example, right? Okay, I'll show a little bit more. Here's our example. Here's example in C++. Hold on, let me show you C++ example. Git stash, git checkout, C++, right? So that you understand the C++ problem. Here's the C++ code. We have a tree where every node is like the list of children, right? So we construct a very big tree which looks like a list, basically like a singly linked list, and we want to like calculate the amount of nodes in the tree. So we start with the current node being 1, and then we go over all the children, and then we call this function recursively, right? The tree itself is allocated on the heap, right? But when I call this function recursively, the recursive function call happens on the stack. It doesn't matter where the tree is, where this data is stored. You know? Kinda funny, I got out of system memory because I infinitely recursed C++ stackless coroutine async function. Yeah. C++ bad? True. But yes, so like we want to basically, instead of running out of stack, we want to like run out of system memory instead, right? That's literally the solution that I'm trying to do here. Because stack is limited, we only have like 4 megabytes or something by default, unless you change it. So we move that into the heap, which we can run out of too, but we have like I have 32 gigs on this PC, right? Should be enough, I think, for most things that I'm trying to do. But 4 megabytes, yeah, I guess the other solution is just to increase the stack size. I remember when we were doing the competitive programming stuff, that's literally what we were doing. We were increasing the stack size to like a gigabyte or something like that, so that our algorithms actually worked, because they would not work otherwise. Do you guys do that? Would local scope the function iterator? Would local scope the function? We want to look at the C++ code, right? Would local scope the function iterator? Hold on, I don't understand this question. Would local scope the function iterator place on the stack? The iterator, this variable is on the stack, and so is the tree, so is the result local variable, and so is the tree pointer. So like one stack frame contains the pointer, which is like what, this is 8 bytes, right? This is 4 more bytes, and the iterator of the vector is like a little more bytes. So like every time we like call this function recursively, we add those bytes to the stack, right? I don't know how you do anything meaningful without increasing the stack size. Well, that's what I'm trying to do, right? I'm offloading the stack into the heap. So when I'm trying to call recursive function, I'm doing that not on the stack, but on the heap instead. I can show you, like, I don't know how to do this in C++. You can do this with coroutines, I guess, similarly to how we do it in Rust. But in Rust, what I end up like, so I'm making a library that allows you to do that easily, right? So here's the code. This is the normal recursive function.
For the stack over heap.
For the stack over heap, thank you. So here's the recursive function. I guess I don't need like to have the leaf. I can do like in C++, I just had like the structure with vector inside. Could do the same here, I guess. So like this over here, stack overflows, right? But this over here does not stack overflow. This is a copy-pasted function, but we add async on top of this, so it's like the coroutines, and then over here we say that we decurse this function, so it's no longer actually a recursive function call over here. We make it decursed. It's an easy to do with a lambda. Can you show me how you do it with a lambda easily? If you, like, you still need to call the lambda, right? Like, I don't understand now, what do you mean by it's easy to do with the lambda? Like, where do I put the lambda? Create the lambda and it does the thing. What do you mean by create a lambda and it does the thing? Does anyone understand what Coffee Lava is saying? Which one of these is a lambda? Like over here, this is a function, and you want me to like call a lambda instead of calling a function. I mean, the lambda is going to allocate on the heap, but you need to call it still. When you call the lambda, which is allocated on the heap, it doesn't matter where the lambda itself is allocated. You are going to call it, and you are going to like still going to grow the stack. Coffee lava is the lambda. Is lambda the equivalent to the skill issue? Like over here, how do you do the lambda in C++? Let me just Google it real quickly. Lambda C++. There's like some square brackets or some shit. Captures and then body, right? So we literally just do this and then we do that, right? With that. So we construct this lambda and then what? And then I just like call it immediately by like doing this. Is that what we want to do? Wait, hold on. Git checkout C++. Git stash. Git checkout C++. Git. Ah! Remove this file. Git checkout C++. Just cpp. Error, it is not captured, so I need to like capture the it here, right? Expected semicolon. We need to return, I guess, from inside the lambda, right? Is this the solution that you're proposing? Am I trying to do this in C++ or in Rust? I mean, I'm solving this in C++. So there you go. Like it's like this still sec faults over here. I'm not sure what you mean. Like because like calling a lambda is no different than calling a function, right? It doesn't matter. It's the same thing. I'm trying to do it in Rust, but it should be possible in C++ with the coroutines in C++. Extrapolate the iterator to a simple while loop. Well, that's what I mean. Like you can refactor the algorithm to be no longer recursive. Yes, you can do that. Coffee Lava is trying to be smart again. It's a daily issue. Like first of all, I'm not even sure how to rewrite this into a simple while loop, right? Because so like we do calculate the nodes. We do it in the depth first search fashion, right? So instead of doing a DFS, we could write a BFS, which would be a loop, and we would like have the queue of the vertices that we are like that we have been visiting, right? So so by doing this, the BFS would be not recursive, DFS is recursive, and like we could solve it that way. But this means like using a different algorithm, which means changing your code. Sometimes it makes the code less readable and shit. You just read how it's going? Hello. It's going great. I'm writing some, ignore the C++ code. I'm writing some Rust. I need to stash pop, I think. All right. Let me see. I'm just trying to like improve the performance here a little bit. Import bin. So this is what we need to do. How do I convert? So what I have is I have a mutable pointer to the dynamic trait object, and I want to convert this to the pin mut, right? Pin. Is there any unsafe stuff? Let me see. Docs std pin. Can I have from? How do I construct a pin? See the pin module. Discuss language going to have threads or event loop. Threads is an operating system feature. It's not a language feature. So is event, and event loop is something that is implemented as a library, not in a language. I don't know. So like the language is not going to have any of those things. It's going to have an interface into the operating system threads, and it's going to have a library which has the event loop, I guess. Unless you count libraries as part of the language. Then the answer is yes, it's going to have both, I guess. Like we want to have both the threads and like green threads, futures, coroutines, all that shit. I think we do std pin pin. Where's the documentation for this? Can I just pin the pointer or something? Pin the pointer. Like what does this give me? This gives me a pinned mutable reference to the pointer, right? And then I can say f is f map unchecked mode, I guess. Since I'm unsafe anyway, it doesn't matter. F, and then we just do mute star f something, maybe. So now f becomes the exactly the thing that I want it to be, and then I can just pull it directly, right? Shit, how did I get here? Okay, hold on, it's compiling. If it's compiling, does it mean that it works? I'm pretty sure that one of the things that I forgot about is like the safety of like the deallocation. I'm like or something. Let me have it to do somewhere. To do drops. You know, like the destructors and how they work. Cargo test. Okay, I reduced for 40 milliseconds more here, I guess, is what I did. Cargo flame graph. Let's profile again. Let me see. Cursed. So I'm allocating over here. This is the allocator, right? This is the arena. So inside the arena, I'm spending this much time. Can I have the arena not spend this much time in the arena? Huh? Do I just use the arena like somehow differently, or is like the fact that I am 3 times slower than the stack is okay maybe already, because like something, you're remembering why you stopped coding. Why you stopped coding what? I mean, I usually don't code this kind of shit. I usually never touch unsafe Rust. I don't care about performance usually. I'm just like, oh, doing an experiment today. Just add release in there. The release is there. The release is there. We are running the test with the release. The problem is like like in order to get to the same performance as the normal recursive function, we need this to run in 100 milliseconds, but it's running in 269, which is kind of nice, but you know, if it was just 69 without the 2 here in the front would be nicer. But I guess that's not possible because like I cannot really like run faster than the normal recursive function, right? So I'm like 2.5 times slower or something like that. Wait, can I change the stack size? Rust set stack size. I just want to know how much like how fast does the thing work In GCC, you would do this Rust C-link arguments. Yeah. Oh wait, but it's the thread. Hold on. Rust test thread test stack size, because whatever stack size of threads used by cargo test. Rust means stack. Okay, there you go. There you go. Hold on. Let's just have a gigabyte of the stack, right? This is what? This is 100 megabytes of stack or something. Cargo test. Let's have this. Right? Ah, shit. How did I do that? So let me just run the test, which is broken, which is like the thing. It still overflowed the stack. Wait, what? Rust means stack. Does it not no longer work? Or is 100 megabytes not enough for me? Let's just give it a gigabyte. Oh, there you go. Yeah. So like this is the time of the normal recursive function. It is 91 milliseconds, right? And my and then my stuff is running is 269, 67, right? So 267 divided by 91. I'm 3 times slower. Is that okay? You mean something like this? All right, let's see. Coffee lava. Привет. Здорово. You don't have anything recursive here. Oh wait, hold on. You have a generic lambda. You start by having a привет. Okay. And then you call this with the same stuff. Hold on. If x is more than this, then that. Return that. Auto f. New t. I heard some people complain about the Rust syntax. What the shit is this? Check the output. 100,000. Yeah, but like, what do you do here? Let me just try to understand what you're doing here. You have a pointer to the float. Float x 0. Do you increase? You do plus plus on a float? No, that's cursed. And then over here you do the plus plus on the y, but without the brackets. Why? You're just showcasing how do you need to know C++ to get handle of Rust? Not really, but like, I mean, understanding how C++ or C works helps with understanding how Rust works, because they work like basically the same. Like, I mean, not really, but like, I mean, yeah. I guess C is not necessary. I don't know. The ideas are the same, the implementation differs sometimes. What is this curse thing? Oh, okay, hold on. We are increasing this. If we increase this too much, then we stop. Otherwise, we do this. I think the problem is that this is a tail recursive program. So that's a big difference. If you run something that is tail recursive, then this is going to be optimized by tail call optimization, right? So I'm not sure what you're like. Are you showing to me that this does not Stack Overflow because it gets optimized? You know TypeScript? Can you do Rust? I mean, there's a lot of people who come to Rust from JavaScript. I know that. There's like not everyone who's coming into Rust is like, my first use case for Rust personally was replacing JavaScript actually, because I was improving the speed of the browser. Yeah. I was using the I was compiling Rust through the scripting to like ASM.js or something, because the WebAssembly was not even there yet. It was just like appearing. Yeah. I mean, you don't need to know C or C++ to try Rust. But how do you do CSS in Rust? Well, have you... I don't know. Hold on. A Rust Bevy UI examples. Like they literally have they literally have CSS there. This example is running WebGL2 and it should work in most browsers. Let's see if it works. Here's the code for it. Here's the code for it. Look at this. Style. We have width, which is 200 pixels. We have border, which is 2 pixels. You know, this is basically CSS here. Background color is sRGB. This shit. You know, we have a flex direction. We have padding. We have row gaps. You know, like those are the things from CSS, right? You're a web dev. How do you start with a system and what is system language, I guess, from scratch? I mean, I don't know. Why does this not work, by the way? Bevy is broken. All right. Or something. System development. I don't know. I never did system development. I mean, what is considered system development? Is what I'm doing right now the decursor? Is the decursor considered the system development here? I'm not sure. Like, if I write unsafe code, does it mean that I'm doing the system development? If I'm doing the pin and I'm working with pointers and doing some unsafe code, does this mean that I'm doing system dev? I don't know. Probably not. What's a system dev anyway? What is system development? Like developing the operating systems? Is that what it is? Because otherwise everything is system, right? What the fuck am I looking at? Emergency change control procedures. I believe what you're doing is fooling around. I'm on a firm belief if you fuck with memory, you are a system dev. Systems development lifecycle and systems engineering. Is this what we mean? Systems engineering? Printed circuit board designs, robotics. I don't know. I don't know what anything means. I like, yeah. I don't know what functional programming is. Now I realize that I don't know what system development is either. I'm using NeoVim with the front end. What really is recursion? Do you know what a monad is? Yeah. Am I going to tell you? No. Do you, Athana? Does Athana know? Wait, hold on. Athana is a TypeScript developer. Do you use the effect TS stuff? Do you use this shit? This is basically like monads, but like not really. The effect system. A monad is just a monoid, is the category of the in defunctors. What's the problem? No problem. You answered correctly. Good job. To understand recursion, you must first understand recursion. Yeah. What's a monoid and the functor? I don't know. Athena can explain these things too, I guess. But yeah, I think monads are not very very cool. In fact, I don't like I'm not a monad enjoyer. I'm more of an effect enjoyer, you know, because like when you're writing something like Haskell, you're always inside the do notation and writing something effectful anyway. So I don't know. Was I doing anything? I have the allocator. Okay, so the problem right now is that I'm just allocating the memory, right? That's literally the problem. What if I allocate a bunch? So like, because I'm assuming that the bump allocator that I'm using here is allocating like a little bit and then like a little bit more once I need it, right? Can I just tell it to allocate a bunch of memory up front? And then I want to see if it's going to like run the same as. Can I do like with capacity? Yeah, with capacity. And Naru Arena with the specified byte capacity. Yeah, there you go. Let's just give it a gigabyte of memory. And let's see what's the performance is going to be. 1 0 0 0 0 0 0 0 0 0. Alright, before the stream crash. No, it is 240. Which is the same amount, no? Cargo flame graph. Let's see the flame graph again. It still is like the allocator is still like taking more than 50% of my time here. The allocator. Oh, it's because like the pointer right. So like actually writing the data. So copying the. Okay, hold on. Copying the data into the allocator, into like the memory. That's what it is, right? It's not actually allocating. It's copying the data into the memory. That is slow. The core pointer right. Because what we do is we first like create the thing on the stack and then move it into the heap. We don't have the in-place construction in Rust, right? So technically the C++ in this case could win, I guess. Maybe. I'm not sure though. So like this over here, this call, the future, this thing is a local variable which we construct on the stack, but when we move it into the allocator, basically, and that and then like it's not the allocation itself, it takes the time. Why am I using Rust for? I don't know. What do you mean why? Why would I use anything else? Rust is the best language ever, right, guys? Everyone in chat agrees, right? Yep. I don't see any no's. Rust. Rust is good. Okay, I think this is just the fastest thing that I can come up with. If anyone else would like to try to improve this code, if anyone understood what I did here today, it's just 100 lines of code in Rust. Then yeah, can do that. Let me just not do the allocation of the 1 gigabyte because apparently this doesn't really like help much. Let's just do this. Use bumpello. No, cast is better, but cast is not ready yet. Yeah, at some point, I'm working on a language, and this is one is going to be done, and it's going to be better than Rust, but it's not there yet. I guess I'm going to finish for today. Tomorrow, we're going to be the to be doing the Ludum there. It starts in 5.5 hours. Is Coffee Lava doing the game jam? I know that TCAP was preparing for it. Cakes never did a game jam, right? Coffee Lava. I don't remember if he did a game jam or not. Lua is the best language. Lua is the best language. Lua uses indexing starting with 1. It's not a programming language. Do you know any programmer who indexes the arrays starting with 1? There is like, it's not like, if you do that, you are not a programmer. I think so. So Lua is not a programming language, you know. A monad is an end functor, a natural transformation, satisfying these laws. These are the laws of a monad. And a monoid is this, satisfying these laws. It's also simple. Has Cakes finished a single project? How many projects does Cakes have? Like, has he the Cakes TD, right? Also like a couple, I don't know. I guess like the tutorials that he did could be considered like finished things, kind of, right? Like if we count every single YouTube video as a separate project, then those are finished, right? You use 0, but you make it start at 1 when users are involved. But the users are not going to be programming, right? When you show it to people who are not programmers, then you replace the 0 with a 1. Rust. Wet as coding. I imagine. CPP. Two-based indexing is better anyway. All right. Let me just go somewhere. Where do you guys where do you want me to send the people coffee lava since you rated? I guess we can go to Practical NPC, for example. He says Ludum there. Is he preparing for the Ludum there? I think that's the issue. Maybe.
Let me see.
Pirate software?
So yeah, Magnetonics, you managed to guide the when was this? At 12:19? Well, that was 20 minutes ago.
Thano is just about to put it up. I can stall a little bit, I guess. Thano is going to be there. What is Thano doing? Like, I don't think I've seen a Thano stream in a while. Last time it was like stuff for 2 hours. Yeah, I guess not that long. Last time I saw your stream, it was doing what? I think it was some C code. Do you still do that? SDL3 yesterday? Or the day before? I don't know. Maybe you're streaming when I'm sleeping, I guess. In 2 hours from now? Yeah, I'm usually like... It's 8:30 p.m. for me right now, right? We are like on the opposite sides of the world. Indie horror dev? I've been there before. Professional game dev. Alright, let's go here. I'm sorry, Coffee Lava, I'm not raiding pirate software on Primogen. I'm too small for them, you know? Key Ender, hello, but I'm ending the stream, so also bye. Bye.